Welcome to this course, where you will gain insights into the advantages of cloud computing and explore a variety of Microsoft Azure solutions that can support various business needs and scenarios. Are you ready to boost your skills in cloud technologies? Then this is the course for you. Imagine you're an IT professional at a tech company that has decided to migrate its IT infrastructure to the cloud to scale its operations and efficiency. To prepare for this transition, you are eager to expand your knowledge in cloud technologies, focusing in particular on Microsoft Azure. Expanding your knowledge of Azure will ensure you're well equipped to navigate and manage the new cloud environment with confidence. This course is crafted by experts in the field, combining their subject matter expertise and industry experience. It provides you with both theoretical understanding and practical skills, along with the ability to solve real-world problems. These are essential for thriving in an entry-level cloud support role. In this course, you'll explore the intricacies of Azure. You'll begin with an exploration of Azure Compute and get hands-on experience with virtual machines, App Service, and Azure Kubernetes Service, or AKS. Not only will you learn to configure these services, but you'll also master troubleshooting techniques specific to operating systems on Azure virtual machines. This knowledge will help you ensure smooth operation in real-world scenarios. Following that, you will examine Azure Networking. Imagine a company that needs to set up a secure and efficient network infrastructure in the cloud. This section will demonstrate how this company should configure its virtual network, implement load balancing, and manage routes to optimize performance and reliability. Understanding these concepts will be crucial as you develop a robust network architecture for your Azure environment. You'll then learn how security is critical for any cloud environment by gaining a thorough understanding of Azure security. You'll explore how to control who has access to your resources through the use of Identity and Access Management, or IAM. You'll also discover how virtual network security groups, or NSGs, safeguard your network, and you'll get introduced to Microsoft Sentinel, a cloud-native security information and event management, or SIEM solution. Through practical exercises, you'll gain the expertise to secure your Azure environment effectively. Each section of the course combines theory with hands-on activities to reinforce your learning. From deploying virtual machines and configuring app services to managing Kubernetes clusters and securing your network, you'll gain practical experience that mirrors real-world applications. Additionally, quizzes and interactive lessons ensure that you understand the material thoroughly and can apply it confidently. By the end of this course, you'll be well equipped to design, deploy, and manage a secure and scalable Azure environment. You'll understand how to leverage Azure's compute, networking, and security services to meet your organization's needs. The knowledge you gain from this course will be a significant asset as you prepare for the AZ-900 Microsoft Azure Fundamentals Certification exam, advancing your career in the process. Best of luck! Imagine you're working on a new application for your employer, but your current hardware setup is holding you back. As your project grows, you need more power, flexibility, and the ability to scale effortlessly. This is where Azure Virtual Machines, or VMs, come in. These virtual computers, hosted in Azure's extensive data centers, provide on-demand, scalable computing power without the hassle of maintaining physical hardware. Azure VMs offer unparalleled control over your computing environment, perfect for scenarios requiring specific configurations or high customization. In this video, you'll explore what makes Azure VMs a versatile and cost-effective solution. You'll discover their use cases, setup considerations, and other available features. Let's start by exploring why more and more organizations are opting for Azure VMs. As mentioned, VMs offer on-demand, scalable computing power at your fingertips. They are one of the many ways Azure lets you leverage cloud resources. Think of them as virtual computers residing within the vast Azure data centers. The beauty lies in the flexibility of virtualization, offering all the benefits without the burden of purchasing and maintaining physical hardware. Furthermore, they offer exceptional control over your computing environment. This makes them perfect for situations where you require specific configurations or a high degree of control over your infrastructure. Azure VMs can be used in numerous ways, limited only by your imagination. Some common applications include development and testing. Azure VMs help you set up a virtual machine quickly and easily with the exact configuration your application requires for coding and testing. Next, Azure VMs allow for applications in the cloud. Maybe your resource demands fluctuate. With Azure VMs, you can effortlessly scale resources up or down based on real-time needs. Pay only for what you use, making it a cost-effective solution. And extended data centers. Azure VMs seamlessly integrate with your organization's existing network, acting as an extension of your on-premises data center. There are several considerations you should make prior to creating your VM, including resource name. Ensure you choose clear and descriptive names for your VMs and related resources for easy identification. You should also choose the geographical location wisely, as this will determine where your virtual hard disks reside. Next, Azure offers a variety of VM sizes catering to different processing power, memory, and storage needs. Determine the ideal size based on your workload, and remember that there might be limitations on the number of VMs you can create. You should also select the operating system that best suits your needs, either Windows or Linux. Customize your VM configuration with additional settings like storage options and network configurations. Another important consideration when creating a VM is to remember that you're essentially building an ecosystem. This can impact billing depending on the additional supporting resources you need, including virtual networks. These act as the communication highway for your VM, enabling it to connect with other resources. A network interface card or NIC. Think of this as your VM's network adapter, allowing it to connect to the virtual network. Also, Network Security Group or NSG acts as a security guard, managing incoming and outgoing network traffic for your VM. And OS and data disks. Imagine separate disks for your operating system and your actual data. This keeps things organized and efficient. Azure VMs include the following features. The beauty of Azure VMs is their global reach. You can create them in multiple geographical regions. Remember, the location you choose determines where your virtual hard disks are stored. Azure also offers features like availability zones and virtual machine scale sets to ensure high availability and scalability for your VMs, making sure your applications are always up and running. The size of your VM significantly impacts factors like processing power, memory, storage capacity, and network bandwidth. However, Azure charges you based on the VM size and operating system you choose, with storage costs being separate. To optimize costs, carefully consider your workload requirements and choose the most suitable VM size. Azure Managed Disks can also automatically handle Azure storage account creation and scalability in the background. All you need to do is specify the disk size and performance tier, and Azure takes care of the rest. When it comes to operating systems, Azure offers a wide selection. You can choose from popular Linux distributions like Ubuntu and CentOS, as well as various Windows Server versions. Finding the perfect fit is easy. Simply browse available distributions through the Azure portal, command line interface or CLI, PowerShell, or even REST APIs. Rest assured, Microsoft optimizes these pre-configured images to run smoothly on Azure. Azure also supports Cloud Init, a popular cloud initialization tool. This simplifies deployments and configurations for your VMs and VM scale sets. Cloud Init allows you to pre-configure settings like users, SSH keys, and packages during the VM creation process, saving you valuable time and effort. In conclusion, Azure VMs empower you with a flexible, scalable, and cost-effective solution for a wide range of computing needs. They offer exceptional control, seamless cloud integration, and a variety of features to cater to diverse scenarios. Whether you're a developer building a test environment, a company scaling your application, or an organization extending your data center, Azure VMs are a powerful asset to have in your cloud computing toolkit. In this video, you'll learn about the various ways you can deploy VMs in Azure, discuss OS integration, and tackle some common issues you might face along the way. By the end, you will have a solid understanding of what deployment means and how to deploy your Azure VMs effectively. Azure offers several deployment options to suit different needs and preferences. In this video, you will explore how to deploy VMs through the Azure portal, Azure CLI, Azure PowerShell, and ARM templates. However, it is important to note that you can also deploy VMs using Azure DevOps and third-party tools like Terraform. Each method has its own advantages, and the best choice depends on your specific requirements and workflow. Let's start with the Azure portal. You'll find the Azure portal to be the most user-friendly option, providing you with a graphical interface to configure and deploy VMs without writing any code. This makes it an excellent choice for those who prefer a visual approach to deployment. Here's how you do it. Firstly, navigate to the Azure portal at portal.azure.com and log in with your Azure account credentials. Next, in the Azure portal, enter Virtual Machines in the search bar and select Virtual Machines under the Services category. Now, on the Virtual Machines page, click on Create and then select Azure Virtual Machine. This will open the Create a Virtual Machine page. Then, under the Instance Details section, enter My VM for the virtual machine name and choose Windows Server 2022 Data Center and Azure Edition x64 Gen 2 for the image. You can leave the other defaults as they are. Now it's time to configure your administrator account. In this section, provide a username such as Azure User, then set a password for the administrator account. Now, under the Inbound Port Rules section, choose Allow Selected Ports and select RDP 3389 and HTTP 80 from the drop-down list to allow remote desktop and web traffic. Once you're happy with everything you have selected, scroll to the bottom of the page and click the Review plus Create button. Once the validation runs, click the Create button at the bottom of the page to start the deployment. Once the deployment is complete, click on Go to Resource to access your newly created VM. By following these steps, you've successfully deployed a VM using the Azure portal. This method is perfect for users who prefer a graphical interface and need to quickly set up and manage VMs without diving into scripting or automation. Next, let's look at deploying VMs using Azure CLI. Azure CLI is a more preferable method, perfect for those who prefer command line tools and need to automate deployments. This command sets a basic name and username. The zvm command creates a VM in the specified resource group with a Windows Server 2022 Azure Edition core image. Azure CLI is a powerful tool for scripting and automation. It's ideal for users who prefer using command line tools and need to automate repetitive tasks efficiently. Another deployment method available is Azure PowerShell, another command line tool tailored for those comfortable with PowerShell scripting. With PowerShell, you can deploy a VM by entering the following command. In this script, new-azvm is the command to create a new virtual machine, while resource group name specifies the resource group in which the VM will be deployed. You can then name the VM and specify the Azure location. Image defines the VM image to be used, in this case, Windows Server 2022 Data Center Azure Edition, while the virtual network name, subnet name, and security group name configure the network settings. Azure PowerShell offers robust scripting capabilities, making it particularly useful for managing Azure resources in a Windows-centric environment. If you're familiar with PowerShell scripting, you'll find it to be an excellent choice for automating complex deployment tasks. Lastly, there are ARM templates for those who prefer infrastructure, such as code or IAC, which offer a declarative method to deploy VMs. By specifying your VM's configuration in a JSON file, Azure Resource Manager handles the deployment process. ARM templates are perfect for repeatable and consistent deployments, especially in complex environments. By defining your infrastructure as code, you ensure that deployments are predictable and maintainable over time. This approach is ideal for those who need to manage complex environments and prefer a programmatic method for infrastructure management. In this video, you focused on the main methods for deploying VMs in Azure. However, it's important to note that Azure DevOps and Terraform are also powerful tools for managing deployments, especially in complex or multi-cloud environments. These tools enable you to achieve advanced automation and seamless integration into CI pipelines, offering enhanced control and efficiency. As you've witnessed, Azure offers a range of deployment methods for virtual machines, each suited to different preferences and needs. Whether you prefer the user-friendly interface of the Azure portal, the automation capabilities of Azure CLI and Azure PowerShell, or the declarative approach of ARM templates for repeatable deployments, Azure has you covered. By understanding these options, you can choose the best approach for your specific scenario, ensuring efficient and effective VM deployments in Azure. Imagine you're managing your organization's website and have opted for a low-cost virtual machine with standard storage to balance performance and cost. One day, customers begin reporting slow page loads and connectivity issues. How would you address this problem? That's where Azure can help. Azure Virtual Machines, or VMs, provide a wide range of configuration options to meet your specific needs. In this video, you will explore these advanced configuration options that Azure offers, focusing on VM sizes, storage options, and common operating system challenges. You'll also discover how to optimize your setup for better performance, reliability, and cost efficiency. Let's start with VM sizes, which Azure offers in a range tailored for different workloads. First up are general-purpose VMs, which are balanced in terms of CPU to memory ratio. They are ideal for testing, development, and small to medium databases. Examples include the B series, DV3, and DV4 series. Next are compute-optimized VMs, which are designed for CPU-intensive applications like batch processing and web servers. Examples are the F-series VMs. You also have memory-optimized VMs. These have a high memory-to-CPU ratio and are suitable for relational databases, in-memory analytics, and other memory-intensive applications. The EV3 and M series are prime examples. Next are storage-optimized VMs. Imagine you need high disk throughput and I/O, such as for big data, SQL, and NoSQL databases. The LSV2 series VMs are designed for these needs. Additionally, there are GPU VMs, which are ideal for heavy graphics rendering and video editing, as well as model training for AI and deep learning. Examples of these include NV and NC series. Last up are high-performance compute or HPC VMs, which are used for the most demanding workloads like molecular modeling and scientific simulations. The H series is an example of HPC VMs. Now let's explore another vital aspect of VM configuration: storage. Azure provides several storage options to match your performance and cost requirements, including Azure Managed Disks, which are the most common storage options for VMs. They come in three types: standard HDD, which is a cost-effective storage type that is suitable for backup and non-critical data. You also have standard SSD, which offers a balance between performance and cost and is ideal for web servers and lightly used enterprise applications. And premium SSD, which is a high-performance storage system for mission-critical applications. It's ideal for production workloads and databases. Next is Ultra Disks. These provide the highest performance with low latency and are designed for data-intensive workloads such as SAP HANA, top-tier databases, and transaction-heavy workloads. You also have temporary disks. Each VM has a temporary disk known as the D drive on Windows VMs. These temporary disks provide short-term storage for applications and processes, but should not be used for storing persistent data. And lastly, you have Azure Blob Storage. Blob storage can be a cost-effective way to store data with options for hot, cool, and archive storage tiers. While VMs provide a wealth of features and configuration options, you may still face several challenges when working with your Azure VM, including boot errors. Having incorrect configurations or missing files could cause your VM to fail during boot. Patch failures that have not been updated or installed correctly could lead to security vulnerabilities. You may also encounter network configuration issues if incorrect settings are applied, leading to connectivity problems. If you have insufficient disk space, it could affect performance and prevent updates. Unpatched systems and misconfigured firewalls can expose your VM to security vulnerabilities. Performance bottlenecks may lead to inadequate resource allocation, which can slow the performance of your VMs. And lastly, backup failures, incomplete or failed backups could jeopardize data recovery. Remember, By addressing these issues promptly, you can ensure that your VMs remain secure, reliable, and efficient from the outset. In conclusion, managing VMs involves balancing performance and cost, a task facilitated by Azure VM. Remember, when customers report slow page loads and connectivity issues, Azure offers robust solutions. This video explored these configuration solutions, covering VM sizes tailored for diverse workloads, storage options ranging from managed disks to Azure Blob Storage, and common OS challenges like boot errors and security vulnerabilities. Addressing these issues will ensure that your VMs operate correctly and maintain optimal performance for your website's visitors. Imagine a scenario where you're managing a platform for your organization during a major online sale. However, during the sale, the website experiences a surge in traffic, leading to performance bottlenecks, all while cyber threats are an increasing risk. How could you ensure that your Azure virtual machines or VMs can handle the increased load and stay secure? This video will explore how to achieve this balance, guiding you through the best practices for optimizing both the performance and security of your VMs. Whether you're overseeing a small number of VMs or managing a large-scale deployment, maintaining optimal performance and robust security is crucial. To begin, let's explore some essential practices for optimizing performance. First is resource allocation, which ensures each VM has the right amount of CPU, memory, and storage. Over-allocating resources can lead to waste, while under-allocating can cause performance bottlenecks. To find the sweet spot, monitor your VM performance regularly and adjust resources based on actual usage patterns. Keep your VM up to date with regular updates and patches. This can improve performance and fix bugs. Use automated patch management solutions to ensure no critical updates are missed. Next, use fast storage options like SSDs for better I/O performance. Consider using storage tiering to balance cost and performance, allocating high-performance storage to critical applications and lower-cost options to less demanding tasks. You should also optimize network configuration settings to reduce latency and improve throughput. Use dedicated network interfaces for high-demand applications and configure quality of service or QoS settings to prioritize critical traffic. Next, robust monitoring tools should be implemented to track performance metrics like CPU usage, memory consumption, and disk I/O. This helps identify and address issues proactively before they impact end users. You should also distribute workloads evenly across multiple VMs to avoid overloading a single machine. To manage traffic efficiently, implement both internal and external load balancers. Lastly, auto-scaling can be used to adjust resources based on demand. This ensures optimal performance during peak times and cost savings during low usage periods. Set thresholds and policies that trigger scaling actions automatically. Next, let's focus on security. Protecting your VMs from threats is just as important as optimizing their performance. First, always apply the latest security patches to your VMs. Use centralized management tools to track and deploy updates consistently. Next, implement strict access controls. Use multi-factor authentication and role-based access control, or RBAC, to ensure only authorized users can access VMs. Regularly review and update permissions. Use firewalls and network segmentation to isolate VMs from potential threats. Implement VPNs for secure remote access and consider using advanced security solutions like intrusion detection and prevention systems, or IDPS. To protect sensitive information, you should also encrypt data at rest and in transit. Use strong encryption standards and manage encryption keys securely. Schedule regular backups to recover data in case of an attack or failure. Store backups securely, ideally in a different location, and regularly test the backup and recovery process. Use security monitoring tools to detect and respond to threats in real time. Implement security information and event management, or SIM systems, to collect and analyze security-related data. And lastly, ensure your VMs comply with industry standards and regulations. Regular audits can help maintain compliance and identify areas for improvement. Document and review compliance efforts continuously. Balancing performance and security is key. Sometimes improving security measures might slightly impact performance and vice versa. Here's how to find the right balance. First and foremost, performing routine audits to evaluate both performance and security can aid in pinpointing areas for enhancement. Next, tools that offer both performance monitoring and security features should be used. This integration simplifies management and improves efficiency. Lastly, train your team on best practices for both performance optimization and security. An informed team is your best defense. Optimizing VM performance and security is an ongoing process that requires vigilance and adaptation to new challenges. By following these best practices, you can ensure your VMs are both efficient and secure, ready to handle any situation your organization faces. Imagine you're developing a web application for your organization with high demands for speed, reliability, and scalability. To meet these demands, you choose Azure App Service. Azure App Service is a fully managed platform that simplifies building, deploying, and scaling web apps. It supports a wide variety of programming languages and frameworks, offering developers a versatile and powerful toolset. With Azure App Service, you can focus on writing code and creating impactful features without worrying about underlying hardware, networking, or infrastructure, as Azure takes care of all that for you. In this video, you'll learn about Azure App Service's features and capabilities and discover why it's the preferred choice for developers seeking efficiency and performance. Let's begin by exploring the diverse language and framework support Azure App Service offers. It includes multiple programming languages such as .NET, Java, Node.js, PHP, Python, and Ruby, allowing you to develop your application in your preferred language. Whether you're creating a simple website, a complex API, or a full-scale enterprise application, Azure App Service caters to your needs. This flexibility lets you leverage your existing skills and code bases, making development faster and more efficient. Next, let's discuss how Azure App Service seamlessly integrates with popular Integrated Development Environment or IDEs like Visual Studio and Visual Studio Code. These integrations offer a streamlined development experience, providing features like code completion, debugging, and integrated source control. This tight integration means you can deploy your applications directly from your IDE, making your workflow smoother and more productive. The ability to work within the familiar environment of your preferred IDE enhances productivity and allows for a more efficient development process. Additionally, with Azure App Service, you can enable continuous deployment from source control systems such as GitHub, Bitbucket, and Azure DevOps, ensuring your application stays current with the latest changes and features. Every time you push a change to your repository, Azure App Service can automatically build and deploy your application, reducing the time between development and production. Continuous deployment also means fewer manual steps, which reduces the risk of human error and makes your deployment process more reliable and consistent. Another brilliant feature is built-in auto-scaling, which can automatically adjust the number of running instances for your application based on demand. During peak traffic times, Azure App Service can scale out to handle the increased load and then scale back down when the demand decreases. This dynamic scaling helps optimize resource usage and cost, ensuring your application performs well without over-provisioning resources. This feature is beneficial for applications that encounter fluctuating levels of traffic, ensuring high performance without resource wastage during periods of low activity. Another awesome thing about Azure App Service is its high availability feature. It's designed to keep your app running smoothly no matter what, with things like load balancing, automated backups, and quick disaster recovery. Basically, it ensures your application is always up and ready for users to access. This high availability is critical for applications that need to be reliable and provide a consistent user experience. You can trust that your application will remain accessible to users even during maintenance or unexpected downtime. Plus, with Azure App Service, you get global reach. This means you can deploy your app in data centers all over the world. By doing this, your app runs faster for users because it's served from locations closer to them. It's all about giving your users a great experience no matter where they are. Whether your users are in North America, Europe, Asia, or anywhere else, they can access your application quickly and reliably. This geographic flexibility helps you deliver a seamless user experience, no matter where your users are located. When it comes to Azure App Service, security is a top priority. It's got all the essentials covered, like SSL certificates, custom domain support, and seamless integration with Entra ID to keep your app safe and sound. These features ensure a secure environment for your applications, protecting sensitive data and meeting compliance requirements. You can easily configure SSL to encrypt data between your application and its users and use Entra ID to manage user access and authentication, making it easier to secure your application and protect your users' data. And lastly, let's discuss monitoring and diagnostics. Azure App Service offers powerful tools like Azure Monitor and Application Insights. These tools give you a clear view of your app's performance, making it easier to spot and fix any issues quickly. You can track metrics like response times, error rates, and user interactions, allowing you to optimize your application for better performance and reliability. These insights enable you to proactively address potential issues before they impact your users, ensuring a smooth and high-performing application. In conclusion, Azure App Service stands out as the ultimate choice for developers seeking speed, reliability, and scalability in web application development. Its robust features simplify the process of building, deploying, and scaling web applications. Whether you're building a simple website or a complex enterprise application, Azure App Service provides the tools and support needed to meet your development goals efficiently and effectively. Imagine you're a developer tasked with launching a new web app for your organization. Ensuring the app functions flawlessly and remains secure is crucial. This is where Azure App Service steps in. Azure App Service equips you with all the tools necessary for seamless web application deployment and effective scaling. Deployment involves transitioning your application from development to a live environment where users can interact with it. Scaling, on the other hand, addresses increased workloads by adjusting resources. This scaling can either be vertical, which enhances the capacity of existing resources, or horizontal, where additional instances of resources are added. In this video, you'll learn about the capabilities of Azure App Service, discover various deployment methods, and learn how to scale your application to accommodate increasing user demands efficiently. Let's start by exploring the various deployment strategies. These include manual deployment, which allows you to move your web app directly from your local environment to Azure. Tools like Visual Studio and Azure CLI make this straightforward. To deploy using this method, you first open it in Visual Studio, then click on Publish. Now connect to your Azure account and select your app service instance. Within a few clicks, your app will go live. Next is continuous deployment. In this case, instead of deploying manually every time you make changes, continuous deployment automates this process. It's like having a robot that updates your app whenever you push new code. To do this, firstly, link your GitHub or Azure DevOps repository to Azure App Service. Then, configure the pipeline so that every time you commit changes, the robot or pipeline automatically builds and deploys your app. You can also choose container deployment. This involves using Docker to package your app into a container. This container includes everything your app needs to run, ensuring it works consistently across different environments. First, simply write a Docker file for your app. After that, build your Docker image locally. From the local terminal where you built the sample image, use the Docker login command to sign in to the container registry. When the sign-in is successful, tag your local Docker image to the registry. Use the Docker push command to push the image to the registry. Uploading the image the first time might take a few minutes because it includes the base image. Subsequent uploads are typically faster. You then simply tell the Azure App Service to use this container for deployment. Finally, let's talk about staging environments. Before rolling out updates to all your users, staging environments allow you to test these changes in a secure, isolated space. Think of it as a dress rehearsal before the big performance, ensuring everything runs smoothly before the main event. To do this, you first, in Azure, create a staging slot, then deploy your app updates to the slot. Next, test it thoroughly and then swap the staging slot with the production slot to go live seamlessly. Now let's discuss the various scaling strategies you have for your applications. First is vertical scaling, which means boosting the power of your existing server. Think of it as upgrading your car's engine to make it go faster. To do this, navigate to your app service in the Azure portal, click on Scale Up, and choose a higher pricing tier that offers more resources like CPU and memory. Next is horizontal scaling, which adds more servers to handle increased load. It's like adding more lanes to a highway to reduce traffic congestion. To do this, set up your app service plan to scale out. Define rules that automatically add or remove server instances based on usage metrics like CPU load and request count. Last is auto-scaling, which automatically adjusts the number of running instances based on traffic. It's like your highway expanding and contracting based on the number of cars. To do this, configure auto-scaling rules in Azure. Set thresholds for scaling actions, such as adding instances when CPU usage exceeds a certain percentage and removing instances when it drops. Another highlight of Azure App Service is how it integrates with other Azure services. These include Azure Monitor and Application Insights, which help you to monitor your app's health and performance. They are like fitness trackers for your application. You can enable Azure Monitor and Application Insights in your app service and use the dashboards to monitor metrics like response times and error rates. Next is Azure DevOps, which provides a full suite of tools for managing your app's lifecycle from planning to deployment. To automate the deployment process, we can create a project in Azure DevOps, set up repositories, and configure build and release pipelines. You also have Azure Virtual Network and hybrid connections, which allow your app to connect securely to other resources, whether in the cloud or on-premises. In the Azure portal, you can set up virtual networks and hybrid connections to securely connect your app service to the required resources. Go to Networking in the App Service portal. Under Outbound Traffic Configuration, select Virtual Network Integration. Select Add Virtual Network Integration. Then there's Azure Functions, which lets you run small pieces of code without managing servers. This is perfect for on-demand tasks like having your own personal butler. To create a function in the Azure portal, just write your code and set up triggers to run it based on specific events. Last up is Azure Front Door and Application Gateway. These services are excellent for global load balancing and enhanced security. They act like gatekeepers, ensuring your app traffic flows smoothly and securely. You can configure Azure Front Door for optimized traffic distribution and Application Gateway for robust firewall protection. Just be sure to establish rules to manage both incoming and outgoing traffic effectively. In summary, Azure App Service offers a powerful and adaptable platform for deploying and scaling web applications. By using various deployment options, scaling strategies, and integrations with other Azure services, you can ensure your application remains highly available, performant, and secure. Imagine being able to create applications with just a few clicks. That's the power of the Azure portal. With its intuitive and user-friendly interface, the Azure portal makes creating a web app easier than ever. In this video, you'll learn how to create a web app step by step using the Azure portal. To get started, sign in at portal.azure.com. Once you have done so, you'll see the Azure portal homepage. Now, on the left-hand menu, click on Create a Resource. This is where you can begin creating any Azure resource. Next, within the Create a Resource pane, you have several categories and a search bar. Since we are creating a web app, you can either search for Web App in the search bar or click on Web under the Azure Marketplace section. Next, click on Create Web App under Web App from the list of options. This opens the Create Web App pane, where you'll configure your new web app. The subscription is where you can choose the Azure subscription you want to use. You can also choose an existing resource group or create a new one by clicking Create New. You then enter a unique name for your web app. This name will be part of your app's URL, so make sure it's unique. You also select Code in the Publish category to deploy code directly. In Runtime Stack, choose the runtime stack your application will use, such as .NET, Java, Node.js, PHP, or Python. In this scenario, .NET 8 was chosen. Now, select the operating system, either Windows or Linux. Then, choose the Azure region where your web app will be hosted. For better performance, pick a region closest to your users. Now you can select the pricing plan that suits your needs. For this scenario, Standard S1 was chosen, which provides a good balance of cost and capabilities. The rest can be left in default, with no changes done. After filling out the form, click Review plus Create at the bottom of the page. This will take you to a summary page where you can review all your settings. If everything looks correct, click Create to begin the deployment process. Azure will now create your web app, and you can track the progress on the screen. You should be aware that this process may take a few minutes. Once the deployment is complete, you will get a notification where you can click Go to Resource to navigate to your newly created web app. You are now in the App Service Overview pane. This is your control center for managing your web app. Here, you can see the URL, monitor performance, configure settings, and more. To view your web app, click on the Browse button or URL provided in the Overview pane. This will open your app in a new browser tab. The default page you encounter confirms that your web app is up and running. This placeholder page, provided by Azure, indicates that your web app is ready for deployment. Congratulations! You have successfully created a web app using the Azure portal. With your app now up and running, you can proceed to deploy your code and begin building amazing applications. The intuitive and user-friendly interface of the Azure portal streamlines the entire process, making it easier than ever to create, manage, and scale your web apps. Now, leverage this powerful platform to develop and deploy robust, high-performing applications for your users. Happy coding! Imagine you're developing a web application for your organization. You have a front end that handles user interactions, a back end for business logic, and a database for storing user data and orders. Traditionally, each of these components is tightly integrated with the operating system, leading to difficulties in deployment, scaling, and ensuring consistency across different environments. This is where containers come into play. Containers encapsulate the application into a single portable package, simplifying deployment across various environments. This concept is central to modern application deployment, but it can be daunting if you're new to the field. In this video, you'll gain an understanding of containers, discovering what they are and how they work. Let's start by breaking down what a container is and why it's essential. A container is a lightweight, standalone, executable package that includes everything needed to run a piece of software, including the code, runtime, system tools, libraries, and settings. This encapsulation isolates the application from the host operating system, ensuring that it runs consistently across different environments. In traditional application deployment, each component is tightly integrated with the OS, leading to challenges in deployment and scaling. With containers, each component runs independently, sharing the OS kernel but isolated from each other. This isolation enhances security, stability, and efficiency. Because they are lightweight and efficient, multiple containers can run on a single OS instance. By sharing the OS kernel while maintaining isolation between applications, they can also maximize resource utilization. However, managing containers at scale can be challenging, which is where container orchestration platforms like Kubernetes come in. By leveraging containers, you can streamline the deployment process, improve application consistency across environments, and enhance scalability and resource efficiency. Services like Kubernetes, an open-source system for automating the deployment, scaling, and management of containerized applications, group containers into logical units for easy management and discovery. Kubernetes handles the scheduling of containers onto a cluster of machines and manages the workload to ensure that the application runs as intended. It also provides self-healing capabilities like restarting failed containers, rescheduling them when nodes die, and killing containers that don't respond to user-defined health checks. One such Kubernetes service is Azure Kubernetes Service, or AKS. AKS is Microsoft's managed Kubernetes service designed to simplify the deployment of Kubernetes clusters in Azure. By offloading operational tasks such as health monitoring, maintenance, and scaling to Azure, AKS allows you to focus on building and running your applications without worrying about the underlying infrastructure. AKS provides the benefits of Kubernetes without the complexity of managing the infrastructure. It also integrates seamlessly with other Azure services, providing enhanced security, monitoring, and scalability. This makes it easier for you to manage your containerized applications and focus on developing your solutions. AKS offers several key benefits, including simplified deployment. AKS automates the provisioning, upgrading, and scaling of resources so you can focus on your applications instead of the infrastructure. It also provides integrated developer tools by working with Azure DevOps, Visual Studio Code, and GitHub to provide a comprehensive development environment. It also has enterprise-grade security through its built-in security features such as Entra ID integration, managed identities, and network policies to safeguard your applications. And with Azure Monitor and Azure Log Analytics, AKS offers essential monitoring and diagnostics of your containerized applications, helping you troubleshoot and optimize performance. These benefits help streamline your workflow, enhance security, and improve the management of your applications, allowing you to focus on what you do best, developing innovative solutions. In addition to these benefits, AKS is engineered to support a well-architected framework. This ensures operational excellence. AKS helps you to manage and automate operational processes, reducing the risk of errors and increasing efficiency. It also ensures reliability with built-in self-healing capabilities and seamless integration with Azure's robust infrastructure. AKS ensures your applications are highly available and resilient. AKS also optimizes resource usage and provides tools to monitor and enhance application performance. And cost management. By leveraging AKS's automated scaling and resource management features to optimize your spending and ensure cost-effective operations. Additionally, Azure offers a variety of container services to meet diverse needs, including the following. Use Azure Red Hat OpenShift to simplify deploying and managing OpenShift clusters on Azure. Use Azure Container Apps for a serverless platform that provides event-driven autoscaling and integrated monitoring. Azure Functions, a serverless compute service, can run event-driven code without provisioning infrastructure. Azure Container Instances offer a fast and straightforward way to run containers with increased security. With Azure Service Fabric, you can deploy and manage microservices and containers, providing comprehensive application lifecycle management. Use Azure Container Registry, which works with Docker and Kubernetes, to manage container storage. Azure Container Registry works by creating and storing containers in Azure Container Registry, just like placing boxes in a secure warehouse. It then keeps track of all your containers, ensuring they are safe and organized. And simply pulls out a container when needed, just like retrieving a box from storage. With these services, Azure ensures that you have the right tools for your container needs, enhancing efficiency, security, and cost management. In conclusion, containerization enables you to package applications with all their dependencies, ensuring consistency across different environments. Kubernetes offers robust tools for orchestrating these containers, while AKS streamlines the process, allowing you to easily scale and manage your applications with minimal operational overhead. By now, you should be familiar with Azure Kubernetes Service, Microsoft's managed Kubernetes offering. Azure Kubernetes Service, or AKS, is designed to simplify the deployment and management of Kubernetes clusters in Azure. With AKS, you can quickly deploy and manage clusters with ease. An AKS cluster consists of virtual machines or VMs running containerized applications, all managed by Kubernetes. By harnessing Kubernetes' capabilities and offloading operational overhead to Azure, AKS makes deploying, managing, and maintaining your containerized applications more straightforward. In this video, you will learn about the various benefits of using AKS and then discover how to create an AKS cluster using the Azure portal. Let's start by exploring the benefits of using AKS for cluster creation. AKS handles many of the complexities of Kubernetes management, such as health monitoring, maintenance, and scaling, allowing you to focus more on developing your applications rather than managing the infrastructure. AKS also integrates seamlessly with Azure services, offering enhanced security, monitoring, and scalability. Additionally, by automating tasks like scaling and resource management, AKS helps optimize costs and ensures efficient resource use. Lastly, AKS provides built-in security features, including network policies and integration with Azure Active Directory for authentication and authorization. Now let's discover how to create an AKS cluster using the Azure portal. First, sign in to the Azure portal and on the home page, select Create a Resource. In the Categories section, choose Containers and then Azure Kubernetes Service, then select Create. Now, within the Basics tab, select your Azure subscription and create a new resource group such as My Resource Group. To avoid impacting your production or development workloads, it's best to create a separate resource group for testing or evaluation purposes. Now, under Cluster Details, set the cluster preset configuration to Dev Test. Enter a Kubernetes cluster name like My AKS Cluster. Next, select a region for your AKS cluster. Now, set the Availability Zones setting to None and set the AKS pricing tier to Free. Leave the default value for the Kubernetes version and ensure the automatic upgrade setting is enabled with Patch. Lastly, set the authentication and authorization to Local Accounts with Kubernetes RBAC. Next, move to the Node Pools tab to add a new node pool. Start by clicking Add Node Pool. Now enter a node pool name such as NP Linux. Next, set mode to User and choose Ubuntu Linux for the OS SKU. You can set availability zones to none and just leave the Enable Azure Spot Instances checkbox unchecked. For node size, click Choose a Size. Just select D2S_V3 and then select. You can leave the Scale method set to autoscale with the default minimum and maximum node counts, and leave the labels and tains as blank. Leave all of the settings on their default values. Once done, select Review plus Create to run validation. After validation is complete, click Create to create the AKS cluster. This process takes a few minutes. Once your AKS cluster is created, navigate to your resource by selecting Go to Resource or browsing to the AKS cluster resource group and selecting the resource, for example, My Resource Group and My AKS Cluster. Great! You've deployed an AKS cluster. Let's connect to it using kubectl, the Kubernetes command line client. With kubectl, you can manage your Kubernetes cluster. This may be already installed if you're using Azure Cloud Shell. If not, you'll need to install it on your local machine. To begin, in your Azure portal, click the Cloud Shell icon at the top, select PowerShell and click Apply. If opening for the first time, select No Storage Account Required, select your subscription and click Apply. This opens a shell environment directly in your browser with all the tools you need. To configure kubectl, connect to your AKS cluster. Use the import-azaks credential command let. Import-azaks credential resource group name My Resource Group name My AKS cluster. This command let downloads the necessary credentials and sets up kubectl for you. Now import your cluster using the name you assigned to your AKS cluster. Now you need to verify the connection by running kubectl get nodes. This command lists the nodes in your cluster. You should see an output similar to this. Great job! You've now explored the various benefits of using AKS and successfully deployed an AKS cluster. Additionally, you've learned how to connect to your cluster using kubectl. By leveraging AKS, you've simplified the process of managing Kubernetes clusters, allowing you to focus more on developing and maintaining your containerized applications. With its integrated tools, cost efficiency, and robust security features, AKS provides a powerful and efficient platform for your containerized workloads. Continue experimenting with AKS to harness its capabilities and enhance your application deployment processes fully. Imagine you've deployed your Azure Kubernetes Service or AKS cluster and there's a sudden surge in online traffic. How will your AKS cluster handle this additional traffic? In this scenario, scaling your AKS cluster quickly will allow it to handle the increased load. This is where AKS management comes in. In this video, you'll discover how to manage your AKS cluster to ensure it runs smoothly even during high traffic periods. By mastering these steps, your AKS cluster will efficiently handle any traffic surge. Begin by navigating to the AKS dashboard in the Azure portal. This is your control center for managing everything related to your AKS cluster. Here you can monitor performance, scale your cluster, update configurations, and much more. One of the first things you'll want to do is ensure your cluster is running smoothly. Let's start by checking the health of your nodes. Open Azure Cloud Shell and run the command kubectl get nodes to get a list of your cluster nodes and their status. This command will return a list of nodes along with their status. If any of your nodes are not in a ready state, you'll need to investigate further. Now let's use the kubectl describe node command to get detailed information about the node and troubleshoot any issues. Next, you should explore scaling your cluster. This allows you to adjust the number of nodes in your cluster based on demand, ensuring that your applications have the resources they need without over-provisioning. To set up auto-scaling, go to the Node Pools tab in your AKS cluster settings. Select your node pool and enable auto-scaling. You can set the minimum and maximum number of nodes here. Auto-scaling helps you manage costs effectively by only using the resources you need. It's a great way to ensure your cluster can handle varying workloads without manual intervention. Another important aspect of managing your AKS cluster is keeping it updated. Regular updates ensure that your cluster has the latest features, security patches, and performance improvements. To update your AKS cluster, navigate to the Settings section and select Cluster Configuration. Here you can choose the Kubernetes version you want to upgrade to. Always review the release notes and test updates in a staging environment before applying them to production. Another crucial aspect of managing any Kubernetes cluster is monitoring. AKS integrates seamlessly with Azure Monitor, providing you with detailed insights into your cluster's performance and health. In Azure Monitor, you can view metrics like CPU usage, memory consumption, and network activity. Setting up alerts can help you stay informed about any issues that need your attention. You can also set up an alert in Azure Monitor by selecting Alerts and creating a new alert rule. Just make sure to define the conditions that trigger the alert and specify the action groups that should be notified. You will explore this further later. Another critical aspect is managing access and identity. AKS supports Entra ID integration, allowing you to manage user access to your cluster using Entra ID identities. Lastly, deploying, updating, and managing applications is straightforward with kubectl and Helm. To deploy an application, you can use a YAML manifest file with kubectl as shown in this example. Managing an AKS cluster involves monitoring, scaling, updating, and securing your resources. By following these steps, you can ensure your cluster runs efficiently and securely. Keep practicing and you'll master AKS management in no time. Imagine your organization is in the process of deploying a new application, but you're facing challenges with scaling, resource management, and maintaining uptime. How can you overcome these challenges and achieve the desired performance? This video will show you how to harness the power of Azure Kubernetes Service or AKS to manage your containerized applications efficiently. You will learn practical steps for managing your containers and explore the nuances of AKS infrastructure before focusing on advanced management techniques. Let's start by gaining an understanding of the core service components used to manage containers effectively in AKS. AKS simplifies Kubernetes by handling the complexities of the control plane, allowing you to focus on deploying and managing applications. The control plane includes components like the Kube API Server, etcd, Kube Scheduler, and Kube Controller Manager, all managed by Azure. Next, you may already understand that nodes run your application workloads and are powered by Azure virtual machines. Each node includes crucial components such as the kubelet, kube proxy, and the container runtime, typically containered for AKS. These elements ensure your containers run smoothly and efficiently. In AKS, nodes are organized into node pools, which are groups of nodes with the same configuration. This setup allows you to scale your applications dynamically based on demand. You can create multiple node pools to support different types of workloads, such as general purpose, memory optimized, or GPU optimized tasks. Managing your resources efficiently is key to maintaining your application's performance and reliability. AKS reserves certain amounts of CPU and memory on each node to ensure the system remains healthy. To view the allocatable resources on a node, you can use this kubecontrol command. This command provides a detailed overview of the node's resources, helping you plan your deployments. Scaling your applications in AKS is crucial for their performance and can be done both horizontally and vertically. Horizontal scaling involves adding more pods, while vertical scaling adjusts the resources allocated to existing pods. Node selectors allow you to define specific nodes for your workloads, ensuring they run in the most suitable environment. This configuration ensures the NGINX pod runs on a Linux node. Another key aspect of managing AKS is node resource groups, which handle the infrastructure for your cluster. When you create a cluster, Azure automatically sets up a node resource group to house the virtual machines, virtual networks, and storage resources. This group is essential for the smooth operation of your cluster, with Azure managing it to ensure everything runs seamlessly. Deployments are the backbone of managing applications in Kubernetes. They define the desired state of your application, including the number of replicas, container images, and resource limits. A basic deployment manifest for an Nginx server would look something like this. This manifest specifies 3 replicas of the Nginx pod with defined resource requests and limits. Another powerful tool for managing Kubernetes applications is Helm. Helm simplifies the deployment process by using charts, which are collections of files that describe a set of Kubernetes resources. You can install and manage applications using Helm charts stored locally or in remote repositories like Azure Container Registry. For example, to deploy an application with Helm, you can use this code. Helm makes it easy to update and roll back applications as needed. For applications that require persistent storage or specific scheduling, Kubernetes offers stateful sets and daemon sets. Stateful sets maintain the state and identity of pods beyond their lifecycle, making them ideal for databases and other stateful applications. Daemon sets ensure that a pod runs on every node or a subset of nodes, which is helpful for log collection or monitoring agents. For example, in a database application, each pod might have its own volume for storing data. If the pod is rescheduled, it will retain its volume and continue to use the same data. Additionally, if you're running a logging agent that collects logs from all nodes, you would use a daemon set to ensure that the logging agent runs on every node. Another brilliant Kubernetes management tool is namespaces. They allow you to organize and manage resources within your cluster and divide cluster resources between multiple users or teams. By default, AKS includes namespaces like default, kubesystem, and kubepublic, but you can create additional namespaces to suit your needs. Networking is also a critical aspect of AKS. Kubernetes uses a virtual networking layer to manage communication between pods and services. Key components include kube proxy, load balancers, and ingress controllers. Network policies help secure your applications by controlling the flow of traffic within your cluster. AKS integrates seamlessly with Azure Networking Services, automating many of these configurations. In conclusion, managing containers with AKS involves understanding its infrastructure, efficiently managing resources, deploying applications, and configuring networking and security. By leveraging these tools and best practices, you can ensure your applications run smoothly and securely. Many organizations struggle with deploying and scaling applications efficiently, particularly during busy periods like an e-commerce company gearing up for the holiday season. Managing these demands is crucial to ensuring your applications can be deployed and scaled adaptively to meet fluctuating needs. In this video, you'll explore container deployment and scaling with Azure Kubernetes Service or AKS and gain a thorough understanding of how to deploy and scale them effectively to handle changing demands. Let's start with deployment. As you already know, to deploy an application, you'll need to create a YAML file that defines the desired state of your deployment. On the screen, you'll notice a basic example for deploying an Nginx web server file that specifies 3 replicas of the Nginx container with defined resource requests and limits. Additionally, you should use the kubectl command line tool to apply the YAML file and deploy your application to the AKS cluster. This command tells Kubernetes to create the defined deployment with the specified number of replicas. As you know, scaling is an essential concept as it allows businesses to adapt to meet their needs. You can scale your application in AKS horizontally or vertically. Horizontal scaling involves adding or removing replicas of your containers. By increasing the number of replicas, AKS distributes the workload across more instances, ensuring high availability and efficient resource utilization. To scale your deployment horizontally, you can use the kubectl scale command. This command increases the number of Nginx replicas from 3 to 5, distributing the load across more instances. Vertical scaling, on the other hand, involves adjusting the resources allocated to each container. This means modifying the CPU and memory limits of your containers to handle more demanding workloads. To vertically scale your containers, update the resource limits in your YAML file like this. Then you can apply the updated configuration using kubectl command. This command updates the deployment with the new resource limits, ensuring each container can handle any increased load. One of the standout features of AKS is its autoscaling support, achieved through the Horizontal Pod Autoscaler or HPA. The HPA can automatically adjust the number of replicas based on CPU or memory usage. To set up autoscaling, you can use this kubectl autoscale command. This command configures the HPA to maintain CPU usage at 50%, scaling the number of replicas between 3 and 10 based on demand. In addition to the Horizontal Pod Autoscaler, AKS includes the Cluster Autoscaler. This component automatically adjusts the number of nodes in your AKS cluster. When there aren't enough resources to schedule new pods, the Cluster Autoscaler adds more nodes to the cluster. Alternatively, if nodes are underused, they are removed to save costs. To enable Cluster Autoscaler, you need to specify a minimum and maximum number of nodes in your node pool. Here's an example command using the Azure CLI. This command configures the Cluster Autoscaler to maintain the node count between 3 and 10 based on the current demand. In addition to autoscaling, monitoring is equally crucial for effective scaling. Azure Monitor offers detailed insights into your application's performance and resource usage. You can set up alerts to notify you when resources are under or overused, helping you make informed scaling decisions. In conclusion, deploying and scaling applications in AKS is straightforward when you use the right tools and techniques. You can efficiently manage your containerized applications by leveraging YAML configurations, kubectl commands, autoscaling features, and the Cluster Autoscaler. This ensures they meet changing demands and maintain optimal performance, especially during peak times. With AKS, you can handle the complexities of scaling, so your application is always ready to perform at its best. Updating your Azure Kubernetes Services or AKS is crucial. Imagine managing your organization's AKS and allowing it to become outdated. This could result in missing essential updates necessary for the smooth operation of your systems. This video will guide you through the process of upgrading AKS clusters, both manually and automatically, ensuring your applications stay up to date without any interruptions. Before diving into the how-to, you might wonder why it's essential to upgrade your AKS clusters. There are 2 main reasons. First, upgrades can bring new features, security patches, and improvements. Additionally, regular updates can ensure your applications run smoothly and securely. You should note that without regular upgrades, your cluster could become vulnerable to security threats, and you might miss out on critical patches that protect against these threats. Let's begin with discovering how to manually upgrade your AKS cluster. This involves checking the current version, then choosing the new version, and finally performing the upgrade. This process gives you complete control over when and how your cluster is upgraded. To check your current AKS cluster version, use this Azure CLI command to list the available Kubernetes versions in your region and the current version of your cluster. This will help you understand its current state and see which versions are available for upgrade. Next, use this command to display the available Kubernetes versions for upgrade in your region. This will help you choose the most suitable version for your cluster. Now it's time to upgrade your cluster to the desired version. This step may take some time, depending on the size and complexity of your cluster. Use this command to initiate the upgrade process and ensure your cluster is updated to the new version. Now let's explore automatic upgrades. While manual upgrades offer control, automatic upgrades can save time and ensure your cluster is always up to date. They minimize the effort needed to maintain your cluster and reduce the risk of running outdated versions. You can use this command to enable auto upgrades for a new or existing AKS cluster. This will ensure your cluster always runs the latest version with minimal manual intervention. Additionally, you can set the auto upgrade channel to patch, stable, or rapid depending on your update preferences. The patch channel receives the most critical security and bug fixes, making it ideal for those who prioritize minimal disruption and focus on security. While the stable channel receives stable updates that have been tested thoroughly, it's suitable for most production environments as it balances stability and new features. The rapid channel receives the latest updates quickly and includes new features and enhancements. It's best for development environments or those who want to leverage the latest features as soon as they're available. Another channel available is node image, which automatically upgrades the node image to the latest version. Microsoft frequently provides patches and new images for node updates, but your running nodes only receive these updates if you perform a node image upgrade. Enabling the node image channel automatically will update your node images whenever a new version is available. Additionally, with this channel enabled, Linux unattended upgrades will be disabled by default, and node image upgrades will also apply to obsolete versions as long as the minor Kubernetes version is still supported. You also have the ability to update an existing cluster automatically. This can be achieved using this command, which configures your existing AKS cluster to upgrade automatically within the specified channel. Once you have set up automatic upgrades, it's crucial to monitor the process to ensure everything runs smoothly. Regular monitoring helps verify that upgrades are occurring as expected and that your cluster remains healthy. To check the upgrade status of your AKS cluster, use this command. It provides information on the current auto upgrade configuration and status, helping you confirm that automatic upgrades are correctly set up. In conclusion, whether you opt for manual upgrades to maintain full control or enable automatic upgrades for convenience, keeping your AKS cluster updated is crucial for security and performance. Azure provides robust tools to help you stay current with the latest features and security patches. Remember, regular upgrades ensure your applications remain efficient, secure, and capable of leveraging the latest advancements. By following these steps, you can confidently manage your AKS cluster, ensuring it always runs at its best. Congratulations on completing this first module of the course. Throughout this module, you've gained essential knowledge of crucial Azure services and now have the expertise to use and manage critical Azure resources effectively. But before you move forward, let's take a moment to recap the core topics you have learned. Revisiting this content will ensure you are fully prepared for the upcoming module quiz. You began this module with an exploration of Azure virtual machines, where you discussed the role of Azure VMs in cloud computing, discovering their importance in the Azure ecosystem. You also learned about various deployment methods, including OS integration and everyday challenges. Understanding what deployment means and how to deploy a VM is crucial. Following this, you covered VM sizes, storage options, and common OS challenges before exploring best practices for optimizing performance and security. Additionally, you studied several comprehensive items on Azure VMs that covered best practices for deploying and managing Azure VMs. They emphasized security, scalability, and cost optimization. To reinforce your learning, you engaged in a hands-on activity implementing virtual machine configurations according to specific requirements. Next, you explored the Azure App Service, which included the functionalities of Azure App Service, which provided you with insights into its role in hosting and managing web applications. You also learned about various deployment options, scaling strategies, and how it integrates with other Azure services. You then focused on the practical aspects of deploying web applications using Azure App Service, covering the deployment process, configuration options, and best practices for efficient application hosting. Furthermore, you studied Azure App Services features, benefits, and use cases and gained foundational knowledge of its capabilities. You also focused on scaling strategies for applications hosted on Azure App Service, including horizontal and vertical scaling, auto-scaling configurations, and performance considerations before participating in a hands-on activity where you configured and optimized Azure App Service. In the last part of the module, you were introduced to Azure Kubernetes Service or AKS. This included an exploration of container orchestration and how AKS simplifies managing containerized applications. You also learned the steps involved in deploying AKS clusters, with an emphasis on understanding what a cluster is before discussing the deployment steps. Following this, you covered the steps involved in managing AKS clusters. This content served as a comprehensive guide to AKS, providing documentation on cluster management, security, and best practices for deploying containerized applications while focusing on security, performance, and scalability. Additionally, several demonstrations were provided, including managing containers using AKS, deploying applications and scaling containers, and handling updates within an AKS environment. Lastly, you engaged in another hands-on activity where you had the opportunity to configure and optimize AKS for a given scenario. Great job! You've engaged with various videos, readings, and activities that encompass essential Azure resources and should now possess essential Azure knowledge that will enable you to make informed decisions in a variety of scenarios. This module has brought you one step closer to becoming a cloud support professional. Imagine you have a bunch of computers and servers and want them to talk to each other securely without anyone else eavesdropping. Essentially, that's what a virtual network or VNet does, but in the cloud. Azure Virtual Network is Microsoft's way of letting you create your own private network in the Azure cloud. It's like having your own little corner of the internet where your services can communicate safely and efficiently. In this video, you'll explore the fundamentals of Azure Virtual Network, learning about its essential components and the reasons behind its growing popularity among organizations. But first, let's take a closer look at what the Azure Virtual Network is. Azure Virtual Network is a service that provides the fundamental building blocks for your private network in Azure. It allows various Azure resources like virtual machines or VMs to communicate securely with each other, as well as the internet and on-premises networks. A virtual network is similar to a traditional one operating in your own data center. However, it brings extra benefits to the Azure infrastructure, such as scale, availability, and isolation. But why would an organization choose Azure Virtual Network? Well, there are several compelling reasons. First, Azure Virtual Network enables seamless communication between your Azure resources and the internet, ensuring your applications can reach users globally. VNets also facilitate smooth interactions between different Azure resources, allowing various application components to work together effortlessly. Additionally, they bridge the gap between your cloud and on-premises environments, simplifying connectivity with local resources. Furthermore, all resources within a VNet can communicate outbound by default, ensuring seamless internet connectivity. You can manage these connections using public IP addresses, NAT gateways, or public load balancers. For inbound communication, you can assign a public IP address or use a public load balancer. Additionally, Azure resources can communicate securely within a VNet using virtual network service endpoints to extend private address spaces to Azure services like storage accounts and SQL databases. Virtual network peering allows resources in different VNets, even across Azure regions, to communicate. Another benefit of VNets is that they act as security gatekeepers, filtering network traffic to ensure only authorized data flows through. They also optimize routing network traffic, ensuring data takes the most efficient path to its destination. VNets also filter traffic using network security groups and network virtual appliances and route traffic efficiently with custom route tables and Border Gateway Protocol or BGP routes for on-premises connections. BGP is a protocol that helps different networks share routing information to determine the best path for internet traffic. Another critical benefit of Azure Virtual Networks is integration. VNets integrate seamlessly with Azure services, simplifying the process of building, deploying, and managing your applications in the cloud. Furthermore, Connecting on-premises resources to a VNet can be accomplished via point-to-site VPNs, site-to-site VPNs, or Azure Express Route. Point-to-site VPNs connect individual computers to a VNet through an encrypted tunnel, while site-to-site VPNs link on-premises VPN devices to Azure VPN gateways. Azure Express Route offers a private connection that bypasses the internet entirely. Lastly, through Azure Services integration, VNets enable private access to virtual machines or compute resources. You can deploy dedicated service instances into a VNet, use Azure Private Link, or extend a VNet to services through service endpoints. Now let's explore several critical components of an Azure VNet. Firstly, IP addresses are the unique identifiers for your resources within a VNet. You can assign public and private IP addresses to your resources, enabling them to communicate with each other and the internet. Think of them as the street addresses for your digital assets. Next, address space defines the range of IP addresses available within your VNet. You can customize the address space to fit your specific needs, ensuring you have enough IP addresses for all your resources. It's like planning a new city's layout, ensuring there's enough room for all the houses and streets. Like dividing a large room into smaller sections, subnets allow you to segment your VNet into smaller manageable parts. Each subnet can host different types of resources, and you can apply specific security rules to each one. There are also route tables, which control the flow of network traffic within your VNet. You can create custom routes to direct traffic through specific paths, optimizing the network performance and security. Think of them as the GPS for your network traffic, guiding data packets to their destinations. Next are network security groups or NSGs, which are like the bouncers of your VNet. They control inbound and outbound traffic to and from your resources. You can define rules that specify which traffic is allowed or denied, adding an extra layer of security. Last is virtual network peering. This feature lets you connect VNets to each other, even if they are in different regions. It's like creating a bridge between two islands, allowing resources in different VNets to communicate as if they were on the same network. In a nutshell, Azure Virtual Networks offer a comprehensive suite of components that work together to provide a secure, scalable, and efficient network environment. Whether you're managing traffic, securing resources, or connecting different networks, these components ensure your Azure VNet is up to the task. As organizations migrate to the cloud, understanding Azure Virtual Networks or VNets is becoming crucial for effective network design and security. In this video, you'll explore the fundamentals of Azure subnetting and network security configurations, providing practical insights for configuring virtual networks. Before we dive into the nitty-gritty of Azure subnetting, let's cover some basics. Subnetting is the process of dividing a more extensive network into smaller, more manageable subnetworks or subnets. Segmenting your network into logical parts helps you organize and secure it. Subnetting your network can offer several benefits, including improved network performance. By dividing your network into smaller subnets, you can reduce congestion and improve performance. It also offers enhanced security. Subnets allow you to implement security policies at a granular level, isolating sensitive resources. And efficient IP address management. Subnetting helps in the efficient utilization of IP addresses, preventing wastage. Now let's explore CIDR, or classless interdomain routing. CIDR is all about flexibility in IP address allocation. Instead of sticking to the old class-based system like Class A, B, or C networks, CIDR allows us to specify the exact number of bits used for the network portion of an IP address. This is done using a suffix that follows the IP address, for example, 192.168.0.1/24. Let's break down what the different notations mean. /8 means the first 8 bits are for the network part, leaving 24 bits for host addresses. For example, 10.0.0.0/8 covers IP addresses from 10.0.0.0 to 10.255.255.255, giving you over 16 million usable IP addresses. /16 means the first 16 bits are for the network, meaning the remaining 16 bits are for hosts. For example, 172.16.0.0/16 covers a range from 172.16.0.0 to 172.16.255.255. This provides over 65,000 usable IP addresses. And /24 means the first 24 bits are for the network, leaving 8 bits for hosts. For instance, 192.168.1.0/24 covers IP addresses from 192.168.1.0 to 192.168.1.255, giving you 254 usable IP addresses. CIDR enables you to create subnets of various sizes, where size represents the number of available IP addresses, allowing for more flexible and efficient management of your network address space. You may be wondering if there are restrictions on using IP addresses in subnets. The answer is yes. Azure reserves the first 4 addresses and the last address for a total of 5 IP addresses within each subnet. For example, the IP address range of 192.168.1.0/24 has the following reserved addresses. A network address. Azure reserves this one as the default gateway. Azure also reserves this one to map the Azure DNS IP addresses to the virtual network space. And lastly, a network broadcast address. In relation to IP range, when you see an IP address with the CIDR notation, it defines a range of IP addresses. For instance, 192.168.1.0/24 covers IP addresses from 192.168.1.0 to 192.168.1.255. The range is determined by the number of bits allocated for the host portion of the address. In our example, the /24 notation means there are 8 bits left for hosts, giving us 256 possible addresses. This range includes all the addresses from the starting IP to the ending IP, making it easy to see which addresses are part of the same subnet. Now let's discuss subnet masks, which separate the network portion of an IP address from the host portion. It's usually written in the same format as an IP address, and the mask will correspond to the CIDR notation. For example, a /24 CIDR notation translates to a subnet mask 255.255.255.0. The subnet mask tells devices which part of the IP address is the network and which is for hosts. Now let's talk about securing your Azure Virtual Network. Azure provides several features to help you protect your network. First are NSGs. They are like virtual firewalls that control inbound and outbound traffic to Azure resources. You can link NSGs to subnets or individual network interfaces, applying specific rules to control the flow of traffic. Here are a couple of example rules. Allow HTTP traffic. This rule allows inbound traffic on port 80, enabling web traffic to reach your resources. Deny all inbound traffic. This rule denies all other inbound traffic by default, providing a secure baseline. Next is Azure Firewall, a managed cloud-based network security service that protects your Azure Virtual Network resources. It provides features such as threat intelligence and URL filtering. There is also VPN Gateway, which lets you securely connect your on-premises network to your Azure VNet over a secure VPN tunnel. This is useful for hybrid cloud scenarios where you must extend your on-premises network to the cloud. And Azure Application Gateway, which is a web traffic load balancer that enables you to manage web application traffic. It includes features like SSL termination, URL-based routing, and a web application firewall or WAF. Before we wrap up, you might be curious about how Azure subnetting and network security can benefit your organization. Let's explore some real-world examples that will illustrate their applications. Firstly, imagine you're managing the network for an e-commerce platform. To keep things organized and secure, you create distinct subnets for web servers, application servers, and databases. By applying NSGs, you ensure only necessary traffic flows between these layers. An Azure Firewall adds an extra layer of protection, and a VPN Gateway securely connects your on-premises data center to Azure. This setup ensures that your web servers are accessible to customers while protecting your application and database servers from direct internet access. Next, imagine you have been tasked with deploying a multi-tier application for a large corporation. You set up separate subnets for the web front end, middle-tier business logic, and back-end database. NSGs control traffic flow between these tiers, ensuring that only the necessary communication is allowed. An Azure load balancer distributes incoming traffic across multiple web servers, and an application gateway manages traffic routing and provides additional security features like SSL termination. This structure ensures high availability, reliability, and robust security for your application. In this video, you learned essential Azure subnetting techniques and network security configurations. These insights will help you build a secure, efficient cloud infrastructure, ensuring your applications and data are well protected while providing a seamless and reliable user experience. Cloud computing is a rapidly evolving industry, and Microsoft Azure stands out as a powerful platform for businesses of all sizes. A key to leveraging Azure effectively is understanding how to configure and manage your network infrastructure. In this video, you will be guided through the process of setting up subnets and network security groups or NSGs in Azure, which will help you to create a secure and efficient network environment for your own organization. Let's begin by exploring regions. As you may recall, the region defines the physical location of your resources. Selecting the right region is crucial when setting up Azure VNets and can profoundly impact your organization across various critical factors, including network latency. By placing resources closer to your users, you can reduce latency, ensure faster response times, and provide a better user experience. It also provides availability. Different regions may offer various levels of redundancy and availability, which directly impacts the reliability of your applications. Additionally, choosing the correct region helps ensure compliance with laws and regulations because certain industries and regions have specific regulatory requirements for data residency. And lastly, cost. Resource pricing can vary by region, so selecting a region that aligns with your budget can help optimize costs. By carefully selecting the appropriate region for your VNet, you can enhance performance, ensure high availability, meet compliance requirements, and manage costs effectively. Now let's discuss the Azure portal. Whether it's VNets, subnets, or NSGs, everything can be managed from the Azure portal. Once logged in, you control and configure all aspects of your network from this central interface. By using the search bar at the top, you can search for any resources. For example, you can search for virtual networks and manage them, or network security groups. When setting up a VNet in Azure, several key configurations need to be considered. Firstly, you need to define the address space using a classless inter-domain routing or CIDR notation. For example, 10.0.0.0/16 provides over 65,000 IP addresses. You should also choose a resource group to organize and manage your VNet and associated resources logically. Resource groups help manage costs, access control, and resource lifecycles. And the region, select the Azure region where the VNet will be deployed. The region affects the network latency and availability of regional services. Furthermore, subnets are crucial for segmenting a VNet into smaller manageable sections. They offer some key benefits, including isolation. By applying separate workloads or application tiers, you can have better security and management. Subnets also provide security. By applying different security policies and NSGs to each subnet, you can control traffic flow. And resource management. Optimize resource allocation and network performance by organizing related resources within specific subnets. While subnets offer numerous benefits, there are some challenges to be aware of. Firstly, address space management. Ensure the IP address range for each subnet does not overlap with others within the same VNet. Next, subnet size limits. The smallest subnet size is /29, providing 8 IP addresses, though only 3 are usable. And reserved addresses. Azure reserves the first 4 and the last IP addresses in each subnet for internal use, reducing the number of available IP addresses. Now let's explore the standard settings required for when creating a subnet. This involves several configuration settings. First is the IP address range. Define the CIDR block for the subnet, ensuring it falls within the VNet's address space. Additionally, the starting IP address of the subnet is derived from this CIDR block. And for the size or CIDR notation, you need to specify the subnet size. For example, 10.0.1.0/24 provides 256 IP addresses, but only 251 are usable due to reserved addresses. Additionally, you should note that NSGs can assist you and are essential for securing Azure VNets. They act as virtual firewalls, controlling inbound and outbound traffic to and from network interfaces, VMs, and subnets. There are several benefits to using NSGs, including traffic control. By defining rules, you can allow or deny traffic based on source or destination IP, port, and protocol. They also provide enhanced security. You can protect resources by applying NSG rules to subnets or individual network interfaces. And granular policies. You can create specific rules to manage traffic flow between different parts of your network. Now let's examine several common settings for configuring an NSG, including resource groups. For logical organization and management, be sure to assign the NSG to a resource group. And region, select the region where the NSG will be deployed. Typically, this should match the region of the VNet and the subnets it will protect. Lastly, NSG rules define the security policies applied to your network. The following demonstrates how it should look in the Azure portal. Inbound rules control incoming traffic to resources. Meanwhile, outbound rules control outgoing traffic from resources. Additionally, each rule includes a priority, source or destination IP ranges, port ranges, and protocols. And priority, lower numbers will have higher precedence, so careful planning is required to avoid conflicts. Similarly, outbound rules would follow the same pattern for outgoing traffic in NSGs. Grasping the essential settings and configurations for VNets, subnets, and NSGs is vital for crafting a secure and efficient Azure network. Effective segmentation of your network using subnets combined with the robust security measures provided by NSGs not only optimizes resource management but also significantly enhances overall security. If you were an IT manager in an organization that had recently decided to migrate its operations to Azure, your primary concern would be to ensure that your customer data, payment information, and internal communications remain secure. With the shift to cloud infrastructure, securing network traffic will be your top priority. As more organizations move their operations to the cloud, the demand for robust network security measures has never been greater. Whether you are an experienced cloud architect or just starting in the profession, mastering the best practices for securing network traffic within Azure Virtual Networks or VNets is crucial. So how can you ensure that your Azure VNet is secure? In this video, you'll explore several best practices that will enhance your digital defenses. Let's begin by exploring how Azure Virtual Network works as the foundation of your cloud infrastructure. Just as you wouldn't build a house on shaky ground, you shouldn't skimp on your VNet design. Remember to keep the following key principles in mind. Firstly, segmentation is key. Remember to divide your network into multiple VNets based on your organizational structure and security needs. This approach helps contain potential breaches and gives you more granular control over network traffic. Next, leverage service tags. Azure's service tags are like shortcuts for groups of IP addresses. Using them instead of specific IP ranges can simplify your network management and reduce the risk of configuration errors. Additionally, distributed denial of service or DDoS protection is essential. By enabling Azure DDoS protection standard, you will have a bouncer at the door of your digital nightclub that will keep out unwanted traffic. Lastly, remember that firewalls are your friends. By deploying Azure Firewall for centralized traffic filtering, you will have a super smart security guard that monitors traffic across multiple VNets. Now let's explore the hub and spoke model. Imagine your network is a wheel. The hub and spoke model is precisely what it sounds like, a central hub connected to multiple spokes. You implement it by creating a central hub VNet. This VNet is the central point connecting to on-premises networks and hosting shared services. It simplifies management and enhances security. Next, deploy spoke VNets. These VNets relate to specific departments or workloads and connect to the central hub, ensuring efficient communication and resource sharing. You then connect with VNet peering to establish low latency, high bandwidth connections between your hub and spoke VNets, ensuring seamless communication and data transfer. Next, centralize security by hosting key security services such as firewalls and monitoring tools in your VNet hub. This centralization enhances security and simplifies management. And finally, control internet access by routing internet-bound traffic from spoke VNets. Through the hub VNet, you can apply consistent security policies and monitor traffic effectively. Now let's explore subnets. You might remember that subnets allow you to segment your VNet into smaller manageable parts. They act like the rooms in your digital house. You can arrange them effectively by planning your subnet sizes carefully. Azure recommends a minimum of /27 for most workloads, which will ensure you have enough IP addresses for your resources. You should also ensure you have dedicated spaces by creating separate subnets for critical services like Azure Firewall or VPN Gateway. This will isolate these services and enhance security. Next, implement service endpoints to extend your VNet's private space to Azure PaaS services. This will improve security by keeping traffic within Azure's network. Also, try leveraging Private Link, which will allow private access to Azure and partner services, reduce exposure to the public internet, and enhance security and privacy. And apply subnet-level NSGs at the subnet level to provide a security baseline for all subnet resources, ensuring consistent security policies. Lastly, as you are now aware, NSGs control inbound and outbound traffic to your network resources. Use them effectively by adhering to the principle of least privilege. Allow only the minimum necessary traffic by starting with the default deny rule and adding specific allow rules as needed. This approach minimizes potential attack vectors. Next, use application security groups. Group VMs and define security policies based on these groups. This strategy simplifies management and enhances security. And carefully prioritize rules. NSG rules are processed in order, so place specific rules before general ones. This ensures that critical rules are applied first. You should also conduct regular reviews. Document and review your NSG rules regularly to ensure they remain relevant and effective. This practice helps maintain a secure network. Next, troubleshoot with Network Watcher. Use Azure's built-in Network Watcher tools to validate and troubleshoot your NSG rules. This helps quickly identify and resolve issues. And lastly, control traffic in both directions. Implement both inbound and outbound rules to manage traffic effectively. This ensures comprehensive security for your network. Securing your Azure Virtual Network is not a one-time task, but an ongoing process. Regular reviews, updates, and vigilance are vital to maintaining a robust security posture. By following these best practices, you'll be well on your way to creating a secure, efficient, and resilient cloud network infrastructure. Imagine working for an organization whose application experiences a surge in traffic during busy periods. The single server hosting the application struggles to keep up, causing slow response times for customers. Instead of continuously adding more network capacity, processors, disk resources, and RAM, which is costly and inefficient, you can implement load balancing to manage the traffic effectively. Load balancing is a brilliant service that distributes incoming traffic evenly across multiple servers, ensuring no single server becomes overwhelmed. This approach allows a pool of servers with moderate resources to handle the traffic more efficiently than a single high-performance server. In this video, you'll explore Azure Load Balancer, learning about its features and how it can optimize your application's performance by distributing traffic evenly across your servers. Let's start by exploring how Azure Load Balancer works. It's a high-performance, ultra-low latency load balancing service for all UDP and TCP protocols. It is designed to handle millions of requests per second, ensuring your application remains highly available. Azure Load Balancer is zone redundant, providing high availability across different zones. It ensures optimal network performance through the following ways. First, load balancing rules determine how traffic is distributed to the instances in the backend. And health probes check the health of backend instances, ensuring traffic isn't directed to unhealthy ones. In Azure, you can deploy both public and internal load balancers. A public load balancer maps the public IP and port of incoming traffic to the private IP and port of the virtual machine or VM and handles the reverse for response traffic. By applying load balancing rules, you can distribute specific traffic types across multiple VMs or services, such as spreading web request traffic across various web servers. An internal load balancer distributes traffic to resources inside a virtual network. Azure restricts access to the front-end IP addresses of a load-balanced virtual network, so front-end IP addresses and virtual networks are never directly exposed to an internet endpoint, meaning an internal load balancer can't accept incoming traffic from the internet. But when is the best time to use a load balancer? Azure Load Balancer is best suited for applications that require uptime and high performance under traffic spikes. For example, maybe you need to distribute load during high or unpredictable traffic to prevent server overload, or you need to scale your application by adding servers and ensuring even traffic distribution. Additionally, you may need to maintain availability by redirecting traffic to healthy servers during failures. You may also need to improve response times by managing request distribution based on server load. And lastly, reduce latency and improve user experience by routing traffic to the nearest or least loaded server. However, when is a load balancer not appropriate? Azure Load Balancer is not suitable when you have a web application that doesn't require load balancing running on a single infrastructure as a service VM instance. For example, suppose your web application only receives a small amount of traffic and the existing infrastructure already competently deals with the existing load. In that case, there's no need to deploy a backend pool of VMs or use load balancer. There are several alternatives to load balancer that Azure provides, including Azure Front Door, Azure Traffic Manager, and Azure Application Gateway. Firstly, Azure Front Door works as an application delivery network that provides global load balancing and site acceleration service for web applications. It offers capabilities for your application, including path-based routing, fast failover, a web application firewall, and caching to improve performance and high availability. This option should be chosen in scenarios such as load balancing a web app deployed across multiple Azure regions. Next is Azure Traffic Manager, a DNS-based traffic load balancer that allows you to distribute traffic optimally to services across global Azure regions while providing high availability and responsiveness. Because Traffic Manager is a DNS-based load balancing service, it loads balances only at the domain level. Because of common challenges around DNS caching, it can't failover as quickly as Front Door. Last is Azure Application Gateway, which provides an application delivery controller or ADC as a service. You can use it to optimize web farm productivity by offloading CPU-intensive TLS and SSL termination to the gateway. SSL and TLS termination refers to the process of decrypting encrypted traffic at the load balancer or gateway level. The application gateway operates within a region rather than globally. Azure Load Balancer is a crucial networking service in Azure, distributing incoming traffic across multiple resources to enhance performance and availability. For aspiring IT professionals, understanding Azure Load Balancer is key to building scalable and resilient cloud applications. This video offered essential insights into its functionality, diverse use cases, and comparisons with other Azure load balancing options, equipping you with valuable knowledge for optimizing cloud infrastructure. By now, you're aware that Azure Load Balancer is a high-performance, low-latency solution for distributing network traffic in the Azure cloud environment. Like all other load balancers, it uses a variety of algorithms to route incoming requests effectively. These algorithms, such as round-robin and least connections, help ensure optimal resource use and balanced workloads. In this video, you will further explore Azure Load Balancer, discovering its distribution mechanism and some of the common algorithms that it uses to manage traffic flow. Additionally, you will examine the technical details of its operation, including hashing methods and interactions with backend resources to ensure optimal performance and scalability for your applications. Let's kick things off by talking about some common load balancer algorithms. First is round-robin, which works by distributing requests sequentially across the server pool. It's straightforward, but doesn't consider server load or capacity. Next is least connections. Here, traffic goes to the server with the fewest active connections, which helps balance the load more effectively. There's also weighted round robin, which is similar to round robin, but servers get assigned weights based on their capacity or performance. Next is IP hash. This method uses the client's IP address to decide which server should handle the request, ensuring the client consistently connects to the same server. And last is health-based. This algorithm looks at the current health and performance of backend servers, routing traffic only to those that are functioning correctly and can handle the load. Now, let's focus on the Azure Load Balancer algorithm, which uses a more sophisticated approach. Known as the 5-tuple hash algorithm, it operates behind the scenes by employing a 5-tuple hash to distribute inbound flows. It's called 5-tuple because it uses 5 specific parameters to create the hash. This tuple consists of a source IP address, source port, destination IP address, destination port, and IP protocol number. This algorithm creates a hash based on these 5 parameters to map flows to available servers in the backend pool. The Azure Load Balancer offers several benefits, including Session Affinity Mode, which uses either a 2-tuple or 3-tuple based distribution. This mode can help maintain consistent connections between clients and specific backend servers. This mode has 2 configuration types. Client IP, which is a 2-tuple, specifies that the same backend instance handles successive requests from the same client IP address. And Client IP and Protocol, which is a 3-tuple, specifies that the same backend instances handle successive requests from the same client IP address and protocol combination. Next, Azure Load Balancer operates at Transport Layer 4 of the Open Systems Interconnection or OSI model. The OSI model is a conceptual framework that describes how data is transmitted over a network using 7 distinct layers. Layer 4, also known as the transport layer, is all about efficiently moving data from one point to another, no matter what that data is. That's why the load balancer can handle any TCP or UDP traffic. It doesn't need to know what's in the messages. It just ensures they arrive where they're supposed to go. The load balancer also doesn't terminate or originate flows. Instead, it rewrites the headers of TCP or UDP flows when directing traffic to backend instances. It's also important to note that Azure Load Balancer incorporates health-based routing through its Health Probe feature. These include regular health checks being performed periodically by sending health probe requests to all backend instances. Backend instances also become eligible to receive new traffic flows only when the load balancer's health probe indicates they are healthy. Additionally, if a backend instance fails to respond to a health probe, the load balancer automatically removes it from rotation, preventing traffic from being sent to unhealthy cases. And administrators can also configure the protocol, port, and path for health probes, as well as the probe interval and unhealthy threshold. Azure Load Balancer also offers transparency to the client and the backend pool. It preserves the source IP address of incoming requests, allowing backend servers to see the actual client IP. You should also note that the load balancer doesn't interact with the TCP payload or provide TLS offload. This allows for comprehensive encrypted scenarios where TLS connections end directly on the VM. The capacity for TLS session keying is determined by the type and number of VMs in the backend pool. Lastly, responses to inbound flows always come directly from a backend VM, not the load balancer itself. By combining the 5-tuple hash algorithm with health-based routing, Azure Load Balancer ensures high-performance, low-latency load balancing. This efficient distribution of traffic across healthy backend instances makes it ideal for various applications and scenarios within the Azure cloud environment, offering both performance and reliability. Suppose you managed a web application for your organization that was gaining popularity and experiencing increased traffic. How would you ensure the application could handle this increased load and maintain high availability? In this scenario, you could distribute incoming traffic across multiple virtual machines or VMs using Azure Load Balancer. By correctly configuring load balancing rules, you can efficiently distribute traffic and keep your application responsive. Azure Load Balancer is key to spreading incoming network traffic across multiple VMs. In this video, you'll walk through the different load balancing rules, concepts, and configuration options in Azure Load Balancer, ensuring your network traffic is delivered effectively. Let's start by discussing the types of load balancers available. Azure offers two: a basic load balancer and a standard load balancer. A basic load balancer is suitable for small-scale, non-mission critical applications, while a standard load balancer offers enhanced features and is suitable for production workloads. Both of these load balancers support various rules for configuring traffic to the backend pool. These include 5 main types: load balancing rules, inbound NAT rules, outbound NAT rules, high availability port rules, and health probes. Let's look at each one in a little more detail. First are load balancing rules, which are for inbound traffic only. They determine how incoming traffic is distributed among the instances in the backend pool. A load balancing rule maps a given front-end IP configuration and port to multiple backend IP addresses and ports. For example, you can use a load balancer rule for port 80 to route traffic from your front-end IP to port 80 of your backend instances. Next are inbound network address translation or NAT rules, which forward incoming traffic sent to a front-end IP address and port combination to a specific virtual machine in the backend pool. Port forwarding uses the same hash-based distribution as load balancing. Next, let's discuss outbound rules that configure outbound NAT for all virtual machines or instances identified by the backend pool. This rule enables instances in the backend to communicate to the internet or other endpoints. You should be aware that the basic load balancer doesn't support outbound rules. Now let's move on to high availability or HA rules. An HA port rule is a load balancer rule configured with protocol all and port 0. This rule enables a single rule to load balance all TCP and UDP flows that arrive on all ports of an internal standard load balancer. The system then makes the load balancing decision for each flow based on the following 5-tuple connection: a source IP address, source port, destination IP address, destination port, and protocol. These HA port load balancing rules help you with critical scenarios such as high availability and scale for network virtual appliances or NVAs inside virtual networks. This brilliant feature can help when a large number of ports must be load balanced. Our final rule is a health probe, which assesses the health status of instances in the backend pool. You can configure a health probe during the load balancer's creation. It will then check whether an instance is healthy and capable of receiving traffic. Additionally, you can specify the unhealthy threshold for your health probes. So, when a probe fails to respond, the load balancer stops directing new connections to the unhealthy instances. However, existing connections will remain unaffected by a probe failure. This connection will continue until the application ends the flow, idle timeout occurs, or the VM shuts down. It's important to note that the basic load balancer doesn't support HTTPS probes. If your application needs secure health checks, you'll need to use the standard load balancer. Knowing this helps you choose the right load balancer type for your needs. In conclusion, setting up load balancing rules in Azure is vital to maintaining the reliability and availability of your applications running on virtual machines. With the right configuration, you can ensure your applications remain responsive and operate smoothly even as demand fluctuates. Azure Load Balancer is essential for effectively managing cloud infrastructure and handling increased traffic with ease. Imagine you're working as an IT manager for your organization. It's an expanding business that's recently moved its operations to the cloud using Microsoft Azure. Everything is running smoothly until after several days, you notice some of the internal applications are running slower than usual and customers' data is not being routed to the correct servers. To address these network traffic issues, you discover Azure Route Tables, a crucial tool for cloud networking. This video will guide you through how Azure Route Tables manage network traffic within your virtual networks, enabling you to resolve your company's networking challenges efficiently. So what exactly are Azure Route Tables? Think of them as traffic controllers for your virtual network, constantly directing data packets to their intended destinations. In our earlier scenario, Azure Route Tables would act like a GPS for your cloud data, guiding it through the complex infrastructure of your cloud network and ensuring your applications continue to run smoothly. Azure Route Tables contain three critical components: traffic direction, which guides network traffic to its intended destination; network segmentation, which helps to divide your network into separate sections for better organization and security; and custom routing, which allows you to create custom routes that can override Azure's default system routes when necessary. You may be wondering how Azure Route Tables achieve this. It starts when a user requests data from a service hosted in an Azure network. The routing process then begins, and Azure Route Tables determine the optimal path for the network traffic. This involves multiple steps and considerations that leverage Azure's robust networking infrastructure to ensure efficient data flow and reliable service performance. Firstly, as the request enters the Azure network, it first encounters the default system routes. These system routes, automatically created by Azure for each subnet in a virtual network, provide basic connectivity between subnets and the internet. However, the real power of traffic control comes into play when custom routes defined in Azure Route Tables are applied. Azure evaluates the routes in a specific order of precedence. It starts by checking the user-defined routes in the route tables associated with the subnet where the traffic originates. These custom routes take priority over system routes, allowing network administrators to implement specific traffic patterns that override Azure's default behavior. Azure bases the routing decision on the packet's destination IP address and compares this address against the address prefixes defined in the routes. The route with the longest matching prefix is selected. This allows for granular control over traffic paths, enabling scenarios such as forcing traffic through a network virtual appliance for security inspection or directing traffic to a specific gateway for optimized routing. Azure also uses additional criteria to select the route if multiple routes have the same prefix length. In such cases, user-defined routes take precedence over system routes, giving administrators ultimate control over traffic flow. Once a route is selected, the next hop specified in that route determines where the traffic is directed. This could be a virtual network gateway, another virtual network, the internet, a virtual appliance like a firewall, or even a black hole to drop unwanted traffic. It's important to note that this routing process needs to be more stateless, meaning each packet is evaluated independently. This can lead to situations where outbound and return traffic might take different paths unless explicitly configured otherwise. As the traffic traverses the Azure network, it may pass through multiple subnets, each potentially associated with its own route table. The routing process is repeated at each hop, ensuring that the traffic follows the desired path across the entire network topology. This sophisticated routing mechanism allows for the implementation of complex networking scenarios. For instance, administrators can create hub-and-spoke network architectures, implement traffic inspection and filtering through security appliances, or optimize routes for specific types of traffic or destinations. The flexibility and control provided by Azure Route Tables enable organizations to design network topologies that meet their specific security, performance, and compliance requirements. By understanding and leveraging these routing mechanics, network administrators can ensure that user requests for data from Azure-hosted services are handled efficiently and securely, following precisely defined network paths from source to destination. You've now taken your first steps into understanding Azure Route Tables. While it may seem complex initially, remember that it's all about guiding your data to where it needs to go efficiently and securely. Azure's virtual networks provide robust routing capabilities, empowering you to manage and optimize your own network traffic flows effectively. Whether through system routes or customized configurations, grasping these options is vital for streamlined and secure cloud infrastructure management. This video explores how leveraging Azure routing enhances your network architecture through efficient traffic flow control. Firstly, let's talk about Network Virtual Appliances or NVAs, which are specialized virtual machines used in cloud environments like Microsoft Azure to perform specific network functions. These virtual appliances replicate the functionality of traditional hardware network devices, such as firewalls, routers, load balancers, and VPN gateways in a cloud-based setting. Typically deployed within their subnet in a virtual network, NVAs act as transit points for network traffic, enabling inspection, filtering, and modification of data packets. How NVA and route tables in Azure interact with each other is particularly significant. Route tables are used to define custom network paths, and when combined with NVAs, they provide powerful traffic control capabilities. By creating routes that direct specific traffic to an NVA, administrators can ensure that the appliance processes network packets before reaching their destination. This integration allows for the implementation of advanced security policies, traffic inspection, and network segmentation strategies, enhancing the overall security and efficiency of the cloud environment. Now let's discuss controlling network traffic, which Azure automatically routes across subnets, virtual networks, and on-premises networks. System routes, which are assigned by default to each subnet in a virtual network, control this routing. With these system routes, any Azure virtual machine deployed into a virtual network can communicate with any other in the network. These virtual machines are also potentially accessible from on-premises through a hybrid network or the internet. Whilst you can't create or delete system routes, you can override the system routes by adding custom routes to control traffic flow to the next hop. Every subnet within an Azure virtual network automatically comes with default system routes. These default routes are automatically created and applied to all subnets in your virtual network. They define the basic routing behavior for traffic within the VNet and to external destinations. This network path can be one of the following hop types. A virtual network is a route created in the address prefix. The prefix represents each address range created at the virtual network level. If multiple address ranges are specified, multiple routes are created for each address range. Or internet, where the default system routes any address range to the internet unless you override Azure's default route with a custom route. And none. Any traffic routed to this hop type is dropped and doesn't get routed outside the subnet. By default, an IPv4 private address prefix is created like one of these. Whilst this prefix can also be added for a shared address space, although none of these address ranges are globally routable. This diagram shows an overview of system routes and details how traffic flows among subnets and the internet by default. You can see from it that traffic flows freely among the two subnets and the internet. Azure automatically creates system routes for each subnet in a virtual network. These system routes define Azure's default routing behavior. You can use route tables to override or supplement system routes. When you create a custom route in a route table, it takes precedence over the corresponding system route for that specific destination. Another crucial aspect of controlling network traffic is virtual network peering and service chaining, which connect virtual networks within Azure. This connection allows virtual machines to communicate with each other both within the same region and across different regions. This communication generates additional routes within the default route table, and service chaining allows you to override these routes by creating user-defined routes between peered networks. For example, this diagram shows two virtual networks with peering configured. The user-defined routes are configured to route traffic through an NVA or an Azure VPN gateway. System routes indeed simplify getting your environment up and running quickly. However, in many scenarios, you may need to control network traffic flow more closely. In these cases, you can override the default system routes with user-defined routes, directing traffic through firewalls or NVAs. For example, you might have a network with two subnets and want to add a virtual machine to the perimeter network for a firewall. To do this, you could create a user-defined route or UDR so that traffic passes through the firewall and doesn't go directly between the subnets. You should note that when creating user-defined routes in Azure, you have several options for specifying the next hop type. First is virtual appliance, which refers to a virtual machine running a network application such as a firewall. Next is virtual network gateway. You can use this when you want traffic destined for specific address prefixes routed to a virtual network gateway, or Internet, which routes traffic to the Internet, and none if you want to drop traffic to an address prefix instead of forwarding it to a destination. As witnessed, Azure's routing capabilities provide a flexible framework for managing network traffic. By leveraging system routes, custom routes, and features like virtual network peering, you can create sophisticated network topologies tailored to your specific needs. This adaptability ensures optimal performance, security, and control over your Azure-based infrastructure. Imagine you have a virtual network in Azure with multiple subnets and need to direct traffic between them or securely connect your Azure environment to your on-premises network. Completing these configurations can be daunting, so understanding the different routing options is crucial for optimizing performance and ensuring connectivity in your Azure network infrastructure. Azure offers two primary routing approaches for these scenarios: static routing, where routes are manually defined, and dynamic routing, where routes are automatically learned and adjusted. In this video, you will explore the features, use cases, and configuration aspects of both methods. Let's start with static routing, which you can think of as setting up a fixed route on a map. You know exactly where you want to go, and you define the path beforehand. In networking terms, this means manually configuring a route entry in your Azure network settings. This entry specifies the destination network and the next hop, router, or gateway that the data packet should take to reach that destination. So why would you use static routing? Firstly, simplicity. It's easy to understand and implement, making it suitable for smaller networks with straightforward routing needs. Security, because since routes are manually defined, you have tighter control over network traffic flow, potentially enhancing security. And predictability. Data packets always follow the same predefined path, ensuring consistent and predictable network behavior. Additionally, static routing could be used for several reasons, including connecting to an on-premises network through your Azure virtual network via a VPN gateway, or routing to a specific virtual machine. This helps direct traffic to a particular virtual machine within your virtual network. However, static routing can pose some challenges, including manual configuration, because adding or modifying routes requires manual intervention, which can become tedious and error-prone in more extensive networks, or lack of adaptability, such as static routes not automatically adapting to network changes. If a network device fails or a new path becomes available, you need to update the route manually. Now that you understand the basics of static routing, let's explore dynamic routing. Think of it like a navigation app. You input your destination, and the app calculates the best route based on real-time traffic conditions. Similarly, dynamic routing protocols enable routers to communicate, exchange routing information, and automatically adjust routes in response to network changes. So why use dynamic routing? Firstly, for scalability. It's ideal for large and complex networks where manual route management becomes impractical. Next, adaptability. Dynamic routing protocols automatically detect and adapt to network changes, such as device failures or new connections. And efficiency. Dynamic routing can improve network performance by choosing optimal paths based on real-time conditions. Just like static routing, dynamic routing can pose some challenges, including complexity. Understanding and configuring dynamic routing protocols can be more complex than static routing. And security considerations. Since routes are determined automatically, careful configuration is crucial to prevent unauthorized network access. Now let's discover how to configure these within Azure, starting with static routes. Firstly, you can configure static routes in Azure using the Azure portal, PowerShell, or the Azure CLI. To do so, you'll need to provide a unique name for your route, give the destination IP address range for the route. Next, advise on the type of next hop, such as virtual network, internet, or virtual appliance. And lastly, the IP address of the next hop. Now let's discuss dynamic routing configuration, which Azure supports and offers, providing more flexibility and scalability for your complex networks. Instead of manually defining each route, dynamic routing relies on protocols that allow routers to communicate and share information automatically. Azure achieves this through virtual network gateways, which act as entry and exit points for your virtual network and facilitate connections to other networks. For more advanced scenarios, Azure provides the route server resource, a central hub within your virtual network that manages routing information. Route server uses the Border Gateway Protocol or BGP, a widely used industry standard routing protocol, to exchange routes with your on-premises network and propagate routes between virtual networks. This setup enables highly adaptable and scalable network architectures in Azure. Selecting between static and dynamic routing depends on your specific network needs and complexity. Static routing offers simplicity and control for more minor static networks, while dynamic routing provides scalability and adaptability for larger, more dynamic environments. By understanding the strengths and limitations of each approach, you can make informed decisions to optimize your Azure network's performance, security, and reliability. Efficient data flow is essential. Just as a well-designed transportation system ensures goods move smoothly, optimizing how your network traffic travels within Azure can significantly impact your application's performance, reliability, and cost. This is where Azure's routing preferences come into play, providing you with the control to direct your traffic flow for optimal results. In this video, you'll explore how to optimize network traffic using route configurations with the two main routing options, Microsoft Global Network and Public Internet. Firstly, imagine planning a journey where you can choose between a premium airline that reaches your destination quickly and comfortably, or a budget-friendly connecting flight with different airlines that might add time to your trip. Similarly, Azure offers routing preferences that allow you to decide how your network traffic travels between Azure and the Internet. Each has its own advantages. Let's start with Microsoft Global Network. This method provides top-tier speed and unwavering reliability for your applications. The Microsoft Global Network is the express route. Spanning over 160,000 miles of fiber and connecting to over 165 edge points of presence or POPs globally, this robust network ensures your data travels swiftly and securely and handles traffic by leveraging BGP Anycast, which allows incoming traffic to intelligently enter the Microsoft network at the edge POP closet to the user's location, minimizing latency and ensuring a responsive experience. Similarly, outgoing traffic predominantly stays on the Microsoft network, exiting at the POP geographically nearest to the final destination. This cold potato approach keeps traffic on the Microsoft network for the maximum distance possible, prioritizing performance and making it ideal for latency-sensitive applications. Now let's consider the more budget-friendly approach, the public internet. Cost optimization is a primary concern for many organizations, and routing over the public internet offers a more economical alternative. While latency might be slightly higher than with the Microsoft Global Network, this option still provides performance comparable to other major cloud providers. With this approach, traffic flows by using a method known as hot potato routing. Incoming traffic travels over the public internet until it reaches the Microsoft network edge closest to the Azure region hosting your service. Similarly, outgoing traffic follows the same pattern, exiting the Microsoft network at the edge closest to your service's region before traversing the public internet to reach its destination. This approach minimizes the distance traveled on the more expensive Microsoft network, making it suitable for applications where cost-effectiveness outweighs the need for absolute minimal latency. You may be wondering about the terms hot potato and cold potato. You'll likely encounter these terms again when discussing Azure routing preferences, so let's simplify them. Cold potato routing is when Microsoft's network retains your data, in this case the potato, for as long as possible, similar to a direct flight with minimal transfers. This reduces latency and potential points of failure. In hot potato routing, Microsoft transfers the potato to the public internet sooner, much like switching between airlines on connecting flights. This method prioritizes cost optimization over absolute performance. So how do you know what the right choice for your organization is? This really depends on your specific needs and priorities. If you need to prioritize performance because your applications demand ultra-low latency and maximum reliability, the Microsoft Global Network is the ideal choice, just like opting for a direct flight. Or perhaps you need a cost-effective solution for less latency-sensitive applications. Then the public internet routing option will suit your needs as it offers significant savings similar to connecting flights. It's important to note that not all Azure services support routing preferences for both options. For instance, while the Microsoft Global Network is universally available, the public internet option is primarily supported for compute resources, networking resources, and storage resources or secondary endpoints. Additionally, you need to consider pricing. Egress data transfer pricing differs between the two options, and IP version support. Currently, the public internet routing preference only supports IPv4 addresses. Ultimately, the optimal Azure routing preference depends on your application's unique performance and cost requirements. By understanding the trade-offs between the Microsoft Global Network and public internet options, you can make informed decisions to optimize your network traffic and create a seamless, efficient cloud infrastructure. Congratulations on completing the next module of this course. Throughout this module, you examined the intricacies of Azure networking and security, focusing on crucial components like virtual networks. Before moving forward, let's recap the core topics you have covered to ensure you're ready for the upcoming module quiz. You began with an exploration of Azure Virtual Networks. Here's a quick rundown of what you covered. After learning about the basics of Azure Virtual Networks, you explored various subnetting techniques and network security configurations. This demonstrated the importance of subnetting in network design and how to configure network security to protect your resources. Next, you examined advanced configuration options for subnets and NSGs. This included a study of network security groups or NSGs and how they can be configured to control inbound and outbound traffic. Following this, you read about the best practices for securing network traffic. This covered the various strategies for securing traffic within Azure Virtual Networks, which ensures that your network remains safe from threats. Lastly, you covered network concepts, configuration steps, and troubleshooting, which provided a thorough understanding of how basic and advanced network concepts are developed, along with practical configuration steps and methods for troubleshooting common issues. The next part of the module moved on to load balancing. Here you explored the benefits of the Azure Load Balancer and how using Azure Load Balancer to distribute traffic across multiple servers improves application availability and reliability. You then discussed load balancing algorithms and configuration settings, including various algorithms used by Azure Load Balancer and the necessary configuration settings to optimize performance. Following this, you learned about configuring load balancing rules, which demonstrated how to set up rules that define how incoming traffic should be distributed to the backend pool. Then you examined load balancing concepts, configuration steps, and troubleshooting. This section covered the foundational concepts of load balancing, providing step-by-step configurations and common troubleshooting techniques. Lastly, you learned the best practices for optimizing application delivery. This demonstrated strategies that enhance the delivery and performance of applications using Azure Load Balancer, which can ensure your applications run smoothly and effectively. The final part of the module focused on Azure routes, where you learned how to control network traffic using route tables and how route tables can be used to direct traffic within Azure, giving you control over the path that data takes through your network. You also discovered how to configure static and dynamic routes, exploring the differences between static and dynamic routes and how to configure each type to meet your network needs. You followed this up by optimizing network traffic with route configurations. You now know how to tweak route configurations to ensure efficient network traffic flow. Route table concepts, configuration steps, and troubleshooting were then discussed. This provided fundamental concepts of route tables that focused on practical configuration steps and troubleshooting tips to resolve any issues that arise. Lastly, you examined the best practices for optimizing network traffic using routes by setting up and managing route tables to optimize network performance and reliability. Additionally, throughout this module, you engaged with various videos, readings, and activities that provided you with a solid foundation in Azure Networking and Security. With this critical knowledge, you're now better equipped to make informed decisions for your organization, bringing you one step closer to becoming a cloud support professional. Take some time to revisit these topics and solidify your understanding. This recap not only prepares you for the quiz, but also ensures you're ready to apply these principles in real-world scenarios. Keep up the great work as you prepare for the next section of the course. Just like a building's security system, Identity and Access Management, or IAM, controls who can access cloud resources, safeguarding sensitive information. In the digital age, protecting data and ensuring only authorized users, machines, and applications access the right resources is crucial. This is where IAM comes into play. It can secure and manage system interactions efficiently. In this video, you'll explore the basic concepts and core functions of IAM. You'll also discover the processes and standards IAM uses to ensure the secure and efficient management of digital identities and access to resources. Let's start by exploring some of the basic IAM concepts. First, resources. These are digital assets requiring protection and controlled access, such as files, databases, web applications, APIs, devices, or services. Next, users. A user is someone, represented by a digital identity, who needs access to resources. Users can be customers, partners, members, or employees. Digital identities can also represent machines, applications, or workloads. Third, authentication. Authentication verifies the identity of a user or entity before granting access using credentials like passwords, biometrics, or tokens. And finally, authorization determines the access level and actions an authenticated user or entity can perform. At the heart of IAM lies the concept of digital identity. Digital identity is a collection of unique identifiers representing users or entities in a computer system. These identifiers include email addresses, sign-in credentials, government-issued IDs, and more complex attributes like MAC or IP addresses. The three types of digital identities are human identities. These include internal users like employees and external users like customers, consultants, vendors, and partners. Workload identities. These cover software workloads such as applications, services, scripts, and containers. And device identities. These encompass desktop computers, mobile phones, Internet of Things or IoT, sensors, and IoT-managed devices. Understanding these identity types is crucial for securely and efficiently managing identities. Now let's explore authentication and authorization further. Authentication and authorization are often confused with each other, but they serve very distinct functions. Authentication verifies an identity, proving you are who you say you are, whereas authorization grants an authenticated party permission to do something, like allowing an employee to access specific files. In the secure building example, authentication verifies your identity using your keycard, and authorization unlocks the door to grant access after authentication. Authentication typically requires the use of credentials like passwords, biometric data, or one-time passcodes. The industry is moving towards passwordless authentication technologies like multi-factor authentication or MFA, requiring more than one piece of evidence like a security token or fingerprint, and single sign-on or SSO, allowing authentication once to access multiple resources without needing to sign in to each system separately. On the other hand, authorization validates and determines access levels for authenticated users, machines, or software components. It defines what a verified user or entity can do within a system. Within IAM, authentication and authorization standards ensure secure and proficient processes for identifying and granting access to resources. Widely used standards include OAuth 2.0, which allows applications to access resources on behalf of a user using tokens. OpenID Connect, or OIDC, is an authentication layer on top of OAuth 2.0. JSON Web Tokens, or JWTs, securely transmit information as a JSON object. Further standards include Security Assertion Markup Language, or SAML, which exchanges authentication and authorization data using XML. System for Cross-Domain Identity Management, or SCIM, which simplifies user identity management across cloud-based applications. And Web Services Federation, or WS-Fed, which secures the exchange of identity information between different trust domains. IAM uses policies and technologies to provide verified users or entities with secure access. These policies and technologies include identity management, used to create, store, and manage users' digital identities; identity federation, used to enable access across systems using existing credentials; and provisioning and deprovisioning, used to manage the user account lifecycle. The policies and technologies further include authentication and authorization, used to validate identities and grant access rights; access control, used to define and enforce appropriate access to resources; and finally, reporting and monitoring, which is used to generate reports and activity logs for compliance and security. A final aspect of IAM that you should understand before exploring how IAM works is the role of identity providers. Identity providers, or IDPs, like Microsoft Entra ID, Google, Amazon, and Auth0 are crucial components of IAM systems. IDPs play a pivotal role in IAM by creating, maintaining, storing, and managing identity information. IDPs offer authentication, authorization, and auditing services, centralizing policies and processes to monitor user behavior and reduce attacks. Now let's explore how IAM works. IAM orchestrates a series of processes to ensure the secure and efficient management of digital identities and access to resources. The high-level authentication and authorization process is as follows. First, the user initiates an authentication request. Then, the identity provider verifies the user's credentials and sends an ID token to the client application. Next, the user consents, and the identity provider sends an access token to the client application. Then, the access token is used to request resources. And finally, the identity provider validates the access token and grants access to the requested resources. Let's summarize what you've learned in this video. IAM manages access to digital resources through authentication and authorization, helping protect data and maintain secure systems. IAM employs standards, policies, and technologies within the authentication and authorization processes to provide verified users with the appropriate level of secure access. Understanding these essential concepts and how they relate to Azure IAM will help you provide secure and efficient access to resources in a digital environment. Previously, you learned about Azure Identity and Access Management, or IAM, and how it controls access to cloud resources. Another crucial part of access control is managing users, groups, and roles to maintain secure access to digital resources. In this video, you'll explore how to manage users, groups, and roles to enhance effective access control in Azure. Let's start with exploring managing users. Users are individuals or entities represented by digital identities who need access to resources. Managing users involves creating, updating, and deleting user accounts and managing access levels. In Azure, user accounts can be managed through Microsoft Entra ID, a comprehensive identity and access management service that provides secure access to resources. In Microsoft Entra ID, you can create users manually or use automated processes such as integrating with an on-premises Active Directory. Once users have been created, they are assigned unique identifiers and sign-in credentials to track and manage access. Let's explore creating a user in Microsoft Entra ID. First, open the Azure portal and search for Microsoft Entra ID. Next, expand the Manage drop-down menu and select Users. On the Users page, select New User and then Create a New User. On the Create New User pane, enter the required information for the username, name, and password. Once you have completed the required information, on the Review and Create tab, select Create to add the new user. Your new user is now available in Microsoft Entra ID. You can also update user information such as contact details, job titles, and department assignments. Keeping user information current is vital for accurate access management and efficient communication within the organization. Regular updates also ensure that access permissions align with users' roles and responsibilities, minimizing security risks. When users leave or no longer need access, their accounts should be deleted promptly to prevent unauthorized access. Deprovisioning users, which involves revoking access rights and removing user accounts, is a critical security measure to ensure that former employees or contractors cannot access sensitive data. Automated deprovisioning processes can help ensure access is revoked immediately when a user leaves the organization. Next, let's discuss managing groups. Users who need similar access to resources can be organized into groups to manage their resource access effectively. Managing groups simplifies the process of assigning and managing permissions, making it easier to maintain security and efficiency. Groups can be created based on roles, departments, or projects. You might have groups for teams like development, marketing, and sales, each with specific access needs. In Microsoft Entra ID, there are two primary types of groups: security groups and distribution groups. Security groups manage access to resources, while distribution groups are used for email communication. It's important that you create the right type of group based on its purpose. Let's explore creating a group in Microsoft Entra ID. First, open the Azure portal and search for Microsoft Entra ID. Next, expand the Manage drop-down menu and select Groups. On the Groups page, select New Group. On the Create New Group pane, enter the group type, name, and description. For Microsoft Entra roles can be assigned to the group, select No. This means that this group will not have any administrative roles assigned to it. For this example, no members have been assigned. Select Create to create the group. Now that your group is created, you can add users to the group. Users can be added to groups based on their roles and responsibilities. This group-based approach simplifies permission management and ensures consistency. On the Groups page, select the group to which you want to add users. You can also search for the group by entering its name in the search field. Please note that you might need to refresh the page for any newly created groups to appear in the list. Next, expand the Manage drop-down menu and select Members. Select Add Members. In the Add Members pane, search for the user by typing their name or email address. Select the checkbox next to the user in the search results and then select to confirm. You can also select multiple users. Group membership can be managed manually or through dynamic membership rules, automatically adding users based on attributes like job title or department. Finally, groups can be updated to reflect organizational or project changes. For example, if a project team increases or decreases, you can adjust the group membership accordingly. Unused or obsolete groups should be deleted to maintain an efficient directory. Furthermore, regular reviews of group memberships will help you prevent unauthorized access and maintain security. Now let's briefly discuss managing roles. Within Azure IAM, roles are managed through Role-Based Access Control or RBAC. RBAC ensures users have necessary access levels by assigning permissions based on roles, minimizing security risks. These roles, such as Reader, Contributor, and Owner, have predefined permissions based on job functions and responsibilities. You can also create custom roles for specific projects or applications with unique access requirements. Roles can be assigned to individual users or groups. This ensures all members inherit the same permissions, reducing administrative overhead and maintaining consistent access permissions. Furthermore, regular review and updating of role assignments ensure alignment with job functions and organizational changes. This proactive approach maintains security and efficiency by removing access for users who no longer need it, keeping permissions up to date and relevant. You will learn more about RBAC later. Effective management of users, groups, and roles is essential for maintaining secure access to Azure resources. By leveraging Microsoft Entra ID and implementing best practices, you can ensure your IAM strategy supports organizational security and efficiency. Previously, you learned about the fundamental concepts of Azure IAM and how to manage users and groups. You were also introduced to Role-Based Access Control, or RBAC, a crucial part of securing access to digital resources in Azure. Where IAM is like the overall security system that manages access to a secure building, RBAC is the function that assigns specific access rights based on a person's role. Almost like a manager might have access to all office areas in a building, while a maintenance worker only has access to technical rooms. In this video, you will explore RBAC further and how to implement it in Azure. Let's start by discussing a few RBAC core concepts. RBAC is a powerful feature that allows you to manage who has access to Azure resources, what they can do with those resources, and what areas they have access to. RBAC is essential for managing permissions and access to resources within an organization. By regulating access based on user roles, RBAC ensures users have the necessary permissions to perform their tasks while minimizing security risks. Aspects that form part of fine-grained access management include role assignments, role definitions, and scopes. Let's discuss these aspects further. A role assignment involves giving specific permissions to a person, group, or application, also known as a security principal, so they can access certain Azure resources. This is done by assigning a role which defines what they can do to the person, group, or application within a specific area of Azure. For example, you can assign the contributor role to a user at the resource group level, giving them permissions to manage all resources within that group. Next, a role definition is a collection of permissions. It is also sometimes referred to as a role. A role definition lists the actions that can be performed, such as read, write, and delete. Azure includes several built-in roles that you can use. For example, the reader role grants read-only access to resources, while the contributor role grants read and write access, but not the ability to grant access to others. Finally, scopes are the set of resources that access applies to. Examples of scopes are an entire subscription, a specific resource group, or an individual resource. Scopes help you manage permissions by limiting the range of resources a role assignment applies to. For example, you can give a user permission to manage only one specific resource group rather than everything in your Azure account. This way, they can work on the resources in that group without affecting other groups or the entire account or subscription. Let's explore how to assign a role to a user in Azure. First, open the Azure portal in your web browser and sign in with your Azure account. Next, navigate to the resource you want to assign a role to. This step will determine the appropriate scope, which can be a subscription, resource group, or specific resource. For example, to assign a role at the subscription level, go to the subscriptions page and select your subscription. Then, in the Selected Resources menu, select Access Control IAM to open the IAM page. Select Add and then Add Role Assignment. On the Role tab, select Privileged Administrator Role and search for the role you want to assign, for example, Contributor. Next, select the Members tab, and for Assign Access to, select User, Group, or Service Principal. Next to Members, choose Select Members. In the Select field, type the name of the user, group, or service principal you want to assign the role to and select them. Finally, select Review and Assign to apply the role assignment. You have now successfully assigned a role to a user at the subscription scope. Next, let's briefly discuss built-in roles and custom roles. Azure provides several built-in roles that you can use. Some of the most common built-in roles are Owner, which provides a user with full access to all resources, including the right to delegate access to others. Then, Contributor, which allows a user to create and manage all types of Azure resources, but does not grant the ability to delegate access. And Reader, which allows a user to view existing Azure resources. In addition to built-in roles, Azure allows you to create custom roles tailored to your organization's specific needs. You will learn more custom roles later. Lastly, let's discuss a few of the best practices for implementing custom roles. Firstly, use built-in roles whenever possible. Built-in roles are designed to cover common scenarios and are regularly updated by Microsoft. Next, the principle of least privilege should be applied by only granting users the minimum permissions they need to perform their tasks. This reduces the risk of accidental or malicious changes. Thirdly, regularly review your role assignments to ensure they are still appropriate for the user's current job functions. And use Azure Activity Logs and other monitoring tools to track changes in role assignments and ensure compliance with your organization's policies. In conclusion, implementing role-based access control, or RBAC, in Azure is a powerful way to manage access to your resources. By understanding and using RBAC effectively, you can ensure that users have the appropriate level of access they need while maintaining security and compliance. So far, you've learned about managing users and groups and how to assign specific permissions to users based on their roles. In this video, you will explore how to create custom roles and assign permissions to users based on their roles in Azure. Let's start by discussing a few core concepts relating to custom rules. To bring it back to the example of managing access to a secure building, imagine having to load specific permissions on the key cards of a particular project team that only authorize access to the project's designated workspace and meeting rooms. Similarly, custom roles in Azure enable you to tailor a set of permissions according to your specific requirements, ensuring a more precise and secure access control to digital resources. Unlike built-in roles, custom roles offer the flexibility to include only the permissions you need, providing a more granular level of control over resource access. A custom role definition also includes the actions that can be performed, such as read, write, and delete. These permissions are specified using Azure Resource Manager or ARM actions, which can be as broad or as specific as needed. Custom roles are defined using a JSON template, which includes properties like the role name, description, permissions, and assignable scopes. A JSON template can be illustrated like this, which has a custom role named Custom Role Example. This allows read and write actions on storage accounts within a specific subscription. Assignable scopes specify where the custom role can be assigned, such as at the subscription, resource group, or resource level. This helps you manage permissions effectively across different levels of your Azure environment. Let's explore how to create a custom role in Azure. First, open the Azure portal in your web browser and sign in with your Azure account. Next, navigate to the subscription, resource group, or resource where you want to create the custom role and select Access Control IAM in the left-hand menu. Select Add and then Add Custom Role. On the Basics tab of the Create a Custom Role page, enter a custom role name and description. Leave the baseline permissions option set to start from scratch. For the purposes of this example, don't make any changes on the Permission tab. Next, on the Assignable Scopes tab, select Add Assignable Scope and select the appropriate scope from the list. This is where you specify where the custom role can be assigned, whether it be a subscription, resource group, or individual resource. Once this is done, the next step is to edit the JSON template. First, select the JSON tab and choose Edit. In the Actions section, add the permissions you want to add to the custom role. For example, Microsoft.storage/storageaccounts/listkeys/action. This permission allows viewing the access keys for the storage account. In this example, the permissions added are for read-only access to the resources. Once you have added the permissions, select Save. Finally, select the Review and Create tab, and once you have reviewed the settings, choose Create to create the custom role. The custom role has now been created. Once the custom role is created, wait for a few minutes and then you can assign it to a user, group, or service principal. Next, let's explore how to assign a custom role to a user in Azure. Navigate to the subscription, resource group, or specific resource where you want to assign the role and select Access Control IAM in the left-hand menu. Select Add and then Add Role Assignment. On the Role tab of the Add Role Assignment page, under Job Function Roles, search for the role you created. Next, select the Members tab, and for Assign Access to, select User, Group, or Service Principal. Next to Members, choose Select Members. In the Select field, type the name of the user, group, or service principal you want to assign the role to and select them. Finally, select Review and Assign to apply the role assignment. You have now successfully assigned a role to a user at the subscription scope. Lastly, let's discuss a few of the best practices for implementing custom roles. First, ensure that custom roles grant only the permissions necessary for users to perform their tasks. This minimizes security risks and potential misuse. Next, periodically review custom roles and their assignments to ensure they remain aligned with organizational needs and security policies. Third, clearly name and describe custom roles to make it easy to understand their purpose and permissions. And before deploying custom roles in a production environment, test them in a development or staging environment to ensure they work as expected. In conclusion, creating and assigning custom roles in Azure provides a flexible and secure way to manage access to resources. By tailoring permissions to meet your organization's specific needs, you can ensure that users have the appropriate level of access they need while maintaining security and compliance. Imagine visiting a bustling city with multiple districts, each with its own buildings, businesses, and residential areas. The city wants to ensure that traffic flows smoothly and safely and that only authorized vehicles can enter specific areas. Just like a team of traffic controllers stationed at key points in the city to monitor and control the flow of traffic, network security groups, or NSGs, manage and regulate the flow of network traffic within Azure, ensuring that only authorized data passes through while blocking unauthorized access. In this video, you'll explore the purpose and functionalities of NSGs and how they maintain network security within Azure. Let's begin by defining what an NSG is. An NSG is a critical component in Azure that helps control the inbound and outbound network traffic to and from various Azure resources. Essentially, NSGs act as virtual firewalls, providing fine-grained control over network traffic based on defined security rules. Like traffic rules in a city that specify who can go where, NSGs contain multiple security rules that allow or deny traffic based on several parameters such as source and destination IP addresses, ports, and protocols. These rules are evaluated and applied in a specific order determined by the rule's priority. The parameters of each security rule within an NSG are defined by 5 key components that include the source, which is the IP address or range from which the traffic originates, the source port range, which is the port or range of ports from which the traffic originates, the destination, which is the IP address or range to which the traffic is destined, the destination port range, which is the port or range of ports to which the traffic is destined, and the protocol, which is the protocol used by the traffic, such as TCP, UDP, or ICMP. The rules within an NSG are processed in priority order. Lower numerical values indicate higher priority. This means that, should multiple rules apply to a specific traffic flow, the rule with the highest priority or lowest number will take precedence. Furthermore, Azure provides a few default security rules in every NSG to ensure a baseline level of security. These default rules include allow VNet inbound, which allows inbound traffic from within the same virtual network, allow Azure Load Balancer inbound, which allows inbound traffic from Azure's load balancer, and deny all inbound, which denies all other inbound traffic. A few other default rules are allow VNet outbound, which allows outbound traffic to the same virtual network, allow internet outbound, which allows outbound traffic to the internet, and deny all outbound, which denies all other outbound traffic. These default rules are crucial as they provide a starting point for your network security. However, they can be overridden by custom rules that you define to meet your organization's specific needs. Now that you have explored a few key aspects, let's discuss how NSGs can be applied within your Azure environment. NSGs can be associated with or linked to subnets or individual network interfaces of virtual machines. In the bustling city analogy, subnets are like districts and network interfaces are like buildings within those districts. When associated with a subnet, the NSG rules apply to all resources within that subnet. When associated with the network interface, the rules apply only to the specific virtual machine or VM connected to that interface. It's also important to understand the order of rule processing for inbound and outbound traffic. Think of it like traffic control in the city. For inbound traffic, Azure processes rules associated with the subnet first, followed by the rules associated with network interfaces. Conversely, for outbound traffic, the rules are processed starting from the network interface first, then subnet. It's almost like traffic controllers having multiple checkpoints before vehicles enter or exit buildings or districts. This order ensures that traffic is thoroughly filtered and potential threats are scrutinized before reaching its destination or leaving the source, providing multiple layers of security. Let's explore a practical example to illustrate how you can use an NSG to protect your VMs and sensitive data within your cloud environment. Imagine a scenario where you have a web server running in a virtual machine within your Azure environment. For inbound traffic, you want to ensure that only HTTP traffic on port 80 from the internet is allowed to this VM and that all other traffic is denied. To achieve this, you would create an inbound security rule within the NSG associated with the VM's network interface or subnet that allows inbound traffic on port 80 from any source. You would then rely on the default deny all inbound rule to block all other inbound traffic. Then for outbound traffic, you want to restrict the VM to only communicate with specific external services. To achieve this, you would define outbound rules specifying the allowed destination IPs and ports while denying all other outbound traffic using the default deny all outbound rule. In conclusion, like traffic controllers in a busy city who manage the flow of traffic to ensure safety and order, NSGs are vital tools in securing your Azure virtual networks. By defining and enforcing rules that control inbound and outbound traffic, NSGs help protect your virtual machines and sensitive data from unauthorized access and potential threats. By understanding and effectively utilizing NSGs, you can significantly enhance the security posture of your Azure environment, ensuring that your applications and data are well protected. By now, you're aware that network security groups or NSGs manage and regulate the flow of network traffic within Azure, ensuring that only authorized data passes through while blocking unauthorized access. In this video, you will explore how to effectively set up and manage NSG rules to enhance the security of your Azure virtual networks. You will discover how to create an NSG, associate an NSG with a subnet or network interface, create security rules, and test and validate rules once they have been created. Let's start by creating an NSG in the Azure portal. First, open the Azure portal and in the search bar, type Network Security Group. Then, select Network Security Groups from the results. On the Network Security Groups page, select Create. In the Project Details section, select your subscription and then select or create a resource group. Then, in the Instance Details section, enter a name for your NSG, like My NSG, and select the appropriate region. Finally, select Review and Create, and then Create to deploy the NSG. After creating the NSG, associate it with a subnet or network interface. First, type Network Security Group in the search field and select your NSG. Next, in NSG settings, select Subnets. Then, select the virtual network and subnet to associate with the NSG. Finally, select OK to complete the association. Once associated, the NSG enforces security rules for the specified subnet or network interface. You can also create inbound or outbound security rules to control network traffic to and from Azure resources. Let's explore creating a security rule in the Azure portal. In your NSG, under Settings, select Inbound Security Rules or Outbound Security Rules. Choose Add to create a new security rule and configure the settings. For source, select any IP addresses, service tag, or application security group. Specify the port ranges. For example, enter an asterisk for all ports, port 80 for HTTP traffic, or port 443 for HTTPS traffic. For destination, select any IP addresses, service tag, or application security group. Next, specify the destination port ranges. For protocol, select any TCP, UDP, or ICMP. For actions, select Allow or Deny. For priority, assign a value between 100 and 4096 with lower numbers indicating higher priority. For name, enter a unique rule name. Optionally, add a rule description. Finally, select Add to save the rule. When an NSG is initially deployed, it includes a set of default rules. These default rules allow all incoming and outgoing traffic within the Azure Virtual Network and all outgoing traffic to the Internet. While the default rules cannot be deleted, you can create new rules with a higher priority to override them. For example, to ensure HTTP and HTTPS traffic can reach your web servers from any source, configure the rule as follows. For source, select any. For source port ranges, enter all. For destination, enter Application Security Group or ASG, Web or any. Add ports 80 and 443. Select TCP as the protocol. Select Allow as the action. Set the priority. Add a name, for example, Allow Web All. Once you have configured your NSG rules, it's important to test and validate that they work as expected. You can use tools like Azure Network Watcher to verify the traffic flow. You can also attempt to connect to your VMs using the configured ports to ensure the rules work as intended. As an example, let's use Network Watcher to verify traffic flow. Open the Azure portal and type Network Watcher in the search bar. Then select Network Watcher from the results. Next, in the Network Diagnostic Tools section, select NSG Diagnostics. Enter or select the values to test, in this example, the inbound traffic to a VM. And finally, select Run NSG Diagnostics to run the test. Once NSG Diagnostics completes, the results are displayed. In this example, the results show 3 security rules assessed for the inbound connection from the subnet, and inbound connections to the VM MyVM36 are denied. Select View Details next to the result to examine the security rules specifics within this NSG. You'll also be able to identify which rule denies traffic. For the MyVM NSG, the Deny VNet Inbound rule denies traffic from the address space of the Virtual Network Service tag to the VM. This happens because the VM uses IP addresses from the address range 10.0.1.0/26, which is included in the Virtual Network Service tag to connect to the virtual machine. Therefore, the connection from the VM is denied by the Deny VNet Inbound rule. Let's discuss a few best practices to help you manage NSGs effectively. Firstly, apply the principle of least privilege by allowing only necessary traffic and denying all other traffic. Next, regularly audit your NSG rules to ensure they align with your security policies and remove any unnecessary rules. Thirdly, enable NSG flow logs to monitor and analyze network traffic. This helps identify and respond to potential security threats. And finally, use application security groups to simplify rule management by grouping similar VMs. Configuring NSG rules is fundamental for securing your Azure environment. By defining and managing these rules, you ensure your network remains secure and efficient. Proper NSG configuration protects your resources from unauthorized access and optimizes traffic flow, contributing to the overall reliability and performance of your Azure infrastructure. By now, you should be familiar with the purpose of network security groups or NSGs and how to effectively set up and manage NSG rules to enhance the security of your Azure virtual networks. In this video, you will learn about advanced NSG configurations, integration with Azure services, automation, and best practices for securing and managing network traffic in complex environments. Having a good understanding of these concepts will enable you to enhance the security and efficiency of your network infrastructure, ensuring a robust and resilient Azure environment. Let's start by exploring augmented security rules and how they can help you streamline your NSG configuration process. NSGs in Azure can be configured with augmented or enhanced security rules. These rules offer greater capabilities than standard rules, allowing you to combine multiple IP addresses, ports, and protocols into a single rule. This feature significantly reduces the complexity of NSG configurations, especially for managing large-scale environments, as it enables handling complex scenarios with fewer rules. This not only streamlines the configuration process, but also improves performance by reducing the number of rules the system needs to process. Next, NSGs can be integrated with Azure services like Azure Application Gateway and Azure Firewall to enhance security and traffic management capabilities. When you integrate NSGs with Azure Application Gateway, the Application Gateway acts as a reverse proxy, providing an additional layer of control over inbound and outbound traffic. This integration significantly enhances the security of your application. Integrating NSGs with Azure Application Gateway helps protect your applications from common threats and vulnerabilities by filtering traffic before it reaches your backend services. Additionally, when you combine NSGs with Azure Firewall, it creates a layered security approach that provides protection at both the network and application levels. Azure Firewall offers advanced threat protection that complements NSG rules, allowing you to enforce comprehensive security policies across your network. Next, you're able to automate NSG management using Azure Policy, Azure Resource Manager or ARM templates, and Azure DevOps. What's more, you can use Azure Policy to enforce NSG configurations across multiple resources. Azure Policy enables you to define rules for various resource configurations and use Azure Policy to enforce them, ensuring the consistent application of NSG settings across your environment. This helps ensure that all your resources comply with organizational standards and security requirements. Then you can automate NSG rule creation and updates using ARM templates and Azure DevOps for continuous deployment. ARM templates define the infrastructure and configurations, while Azure DevOps pipelines automate the deployment process. This enables the automation of NSG deployment and management, ensuring that your security configurations are consistently applied and updated. Furthermore, custom rules can be created to tailor NSG configurations to the specific needs of applications and network architecture. You can define custom rules for specific IP address ranges, ports, and protocols, providing fine-grained control over network traffic. This flexibility enables the enforcement of precise security policies that align with your organization's requirements. For example, you might create custom rules to allow traffic from specific IP ranges used by your partners or to block traffic from regions where you do not conduct business. Next, application security groups or ASGs can be used to group virtual machines logically, making it easier to apply and manage NSG rules at scale. Instead of managing rules for individual IP addresses, you can create ASGs for different tiers of your application, such as web servers, application servers, and database servers, and apply security policies to these groups. This approach simplifies the management of NSG rules and enhances scalability by allowing easy addition or removal of VMs from ASGs without updating the NSG rules. Finally, you can use advanced monitoring tools like Azure Monitor and Network Watcher to track and analyze network traffic, ensuring your security configurations function as intended and identifying potential issues. Azure Monitor provides comprehensive logging and metrics, allowing you to visualize traffic patterns, detect anomalies, and generate alerts based on predefined criteria. Network Watcher offers detailed insights into NSG rule hits, helping you understand which rules are being triggered and how traffic is flowing through your network. Now that you have explored a few of the advanced features you can use to enhance security and efficiency in your network, let's discuss the best practices you should consider when configuring NSGs in complex network architectures. Firstly, use a hierarchical approach to manage NSGs, where common rules are applied at higher levels, like subnets, and specific rules are applied at lower levels, like network interfaces. This approach ensures that common policies are consistently enforced while allowing for specific customizations. Secondly, segment your network into different subnets and use NSGs to control traffic flow between these segments. This practice helps contain security incidents and reduces the attack surface by limiting the scope of access. Thirdly, regularly audit and review your NSG configurations to ensure they remain effective and up-to-date. Use Azure Policy and other monitoring tools to identify and address any deviations from your security standards. Fourthly, integrate NSG logs with Security Information and Event Management or SIEM systems to gain deeper insights into your network traffic and identify potential security threats. This integration allows for real-time monitoring and alerting, helping you respond quickly to incidents. Finally, ensure that your NSG configurations support redundancy and failover to maintain network security and availability during outages or maintenance. Use Azure's built-in high availability features and consider geo-redundant deployments for critical applications. In conclusion, by implementing advanced NSG configurations, integrating with Azure services, and automating management processes, you can significantly boost your network security and efficiency. Regular monitoring, adherence to best practices, and continuous updates are crucial for maintaining a secure and resilient cloud environment. Leveraging these strategies ensures that your network is well protected, efficiently managed, and capable of adapting to evolving security challenges. Imagine you're working as an IT manager for your organization. It's an expanding business that's recently moved its operations to the cloud using Microsoft Azure. As your network grows in complexity, the need for robust security measures becomes paramount. To protect your data and ensure seamless performance, you must implement a strong network security architecture. This involves segmenting your network to isolate different resources, such as web servers, application servers, and databases, thus enhancing security and manageability. In this video, you will explore the essentials of complex network security architectures and the tools and strategies you can use to segment your network in Azure. Let's start by exploring the tools Azure provides for effective network segmentation. Network segmentation is a fundamental security measure that involves dividing a network into smaller, isolated segments to control traffic flow and enhance security. For example, you might separate your network into different segments for web servers, application servers, and database servers, ensuring that only necessary traffic can flow between them. In Azure, you can employ several tools and strategies to segment your network effectively. Let's briefly discuss a few of these. Firstly, subscriptions serve as high-level boundaries within large organizations. They allow for separate billing, management, and compliance policies. Secondly, virtual networks or VNets provide private address spaces within subscriptions. This enables network-level containment of resources. Thirdly, network security groups or NSGs act as firewalls at layer 4 of the OSI model. Based on defined security rules, they control inbound and outbound traffic between and within VNets. Fourth, the Azure Virtual Network Manager, or AVNM, enables global management of VNets. It facilitates the enforcement of security rules across multiple networks. Fifth, application security groups, or ASGs, group VMs under application-specific tags. This simplifies the creation of security rules. Lastly, Azure Firewall is a cloud-native firewall. It offers stateful inspection from layers 3 to 7 of the OSI model, providing comprehensive security. However, just like you need a blueprint before you can use tools to build a house, you need a well-defined segmentation strategy or pattern before you can effectively use Azure's tools to build a secure network. Within Azure, detailed segmentation patterns provide structured approaches you can use to organize and secure your network. These patterns include single virtual network, multiple virtual networks with peering, hub and spoke model, and multiple virtual networks across multiple subscriptions. Let's explore each of these patterns and how you can use them to enhance your network security and efficiency. In a single VNet architecture, all components, such as database servers and web servers, are located within one VNet. This setup is simple and ideal for smaller deployments or environments that don't require extensive segmentation. The key security measures within a single virtual network are NSGs deployed at both the subnet and VM levels. They control traffic flow by enforcing rules that allow or deny specific types of traffic, and ASGs that facilitate the creation of application-centric rules, enabling easier management of traffic between different applications within the VNet. Next, let's discuss multi-viral networks through peering. This model involves connecting multiple VNets through VNet peering, allowing them to communicate as if they're part of the same network. This setup enables seamless interaction between the VNets, similar to being within a single network. The key security measures include explicit peering connections. Each peering connection requires explicit configuration, which allows for the enforcement of security rules and ensures controlled and secure communication. And deploying both NSGs and ASGs within each VNet. These provide further segmentation and control over traffic flow. Next, the hub and spoke model is a common architectural pattern in Azure where a central hub VNet connects to multiple spoke VNets. This model offers significant advantages in terms of centralized security management, simplified traffic management, and scalability. Let's discuss how it provides centralized security management. The hub VNet can host centralized security services such as Azure Firewall, providing a single point to manage security policies and protect resources. Furthermore, implementing DDoS protection in the hub VNet allows for comprehensive defense against distributed denial-of-service attacks across all connected spoke VNets. Next, let's explore how the hub and spoke model simplifies traffic management. By routing traffic through the hub, spoke VNets ensure consistent application of security policies and simplify the management of network traffic. Additionally, NSGs can be utilized in both hub and spoke VNets to control inbound and outbound traffic at the subnet level. And ASGs can be used to group VMs with similar functions, allowing you to apply network security rules collectively and dynamically. The hub and spoke model offers scalability as new spokes can be added easily to the network. This enables seamless scaling without complex reconfiguration. This flexibility supports the growth and evolution of the network architecture. As new spokes are added, NSGs and ASGs can be employed to maintain security and organization. NSGs ensure that traffic to and from the new spokes is appropriately controlled, while ASGs simplify the management of VM security policies within those spokes. Finally, for large organizations with complex environments, managing multiple VNets across multiple subscriptions may be necessary. This is where AVNM comes into play. AVNM enables you to create and enforce security policies across all VNets and subscriptions. It also provides a centralized management interface, reducing your administrative overhead. What's more, AVNM integrates with NSGs and ASGs, further enhancing network security and management. In conclusion, designing and implementing complex network security architectures requires careful consideration of the segmentation strategy and tools you will use to control traffic, enforce security policies, and scale your network infrastructure efficiently. By having a clear architectural strategy and utilizing the appropriate Azure services, you can build and maintain a secure, scalable, and well-organized network in Azure. Have you ever wondered what it's like to receive an alert about a potential security breach in a large corporation? What challenges would you face in quickly identifying and mitigating the threat to protect your organization's data and systems? In this video, you will explore Microsoft Sentinel's core features, including data ingestion, threat detection, investigation, and automated response capabilities. You will learn how you can leverage these tools to manage, monitor, and respond to security threats and ensure the safety of your IT infrastructure. First, let's discuss what a Security Information and Event Management, or SIEM, system is. A SIEM system is a tool that helps organizations keep their computer systems safe. It works by collecting and analyzing data from various parts of the system, such as hardware like computers and servers, and applications like software programs. This system helps manage logs or records of events, sends alerts when something unusual happens, provides visual displays of data, assists in handling security incidents, and allows users to search through data to find specific information. In simple terms, a SIEM system acts like a security guard for all the digital components of a business. For example, it can enable you to detect unusual login attempts from different geographic locations, identify patterns indicative of potential data breaches, and automatically trigger alerts to notify the security team for further investigation and action. Now, what is Microsoft Sentinel? It is a cloud-native SIEM system designed to help security operations teams gain security insights across the enterprise by collecting data from virtually any source. It enables quick detection and investigation of threats using built-in machine learning and Microsoft Threat Intelligence. Think about how this could streamline your threat detection process. Microsoft Sentinel also automates threat responses through playbooks and Azure Logic Apps integration. Unlike traditional SIEM solutions, Microsoft Sentinel does not require the installation of servers either on-premises or in the cloud. As a service deployed in Azure, it allows you to get up and running within minutes through the Azure portal. Sentinel is tightly integrated with other cloud services, enabling seamless log ingestion and native use of other cloud services for tasks like authorization and automation. As an end-to-end security operations tool, Sentinel includes functionalities for data collection, threat detection, investigation, and response. Now let's explore how Microsoft Sentinel works. Imagine consolidating all your security data from multiple sources into one place, simplifying and enhancing your security operations. The first step is ingesting data through data connectors. These connectors allow you to add various services, such as Azure Activity Logs, with a simple selection, while other services like syslog may require some configuration. Data connectors cover a wide range of scenarios and sources, including syslog, Common Event Format or CEF, Trusted Automated Exchange of Indicator Information or TAXI, Azure, and AWS services. After ingestion, data is stored using Log Analytics, which offers the powerful Kusto Query Language or KQL for querying your data. KQL is a powerful query language that allows you to deeply explore and gain insights from your data. Next, you can visualize your data using workbooks in Microsoft Sentinel. Think of workbooks as customizable dashboards. each built using an underlying KQL query. You can quickly create and customize these dashboards to monitor critical security metrics using built-in workbooks or creating new ones from scratch. Next, to proactively monitor your data, Microsoft Sentinel allows you to enable built-in analytics alerts within your workspace. These alerts can be customized, and some are based on proprietary machine learning models from Microsoft. You can also create custom scheduled alerts to suit your specific needs. Furthermore, Microsoft Sentinel offers built-in hunting queries for Security Operations Center or SOC analysts. Analysts can create custom queries to proactively search for threats and investigate suspicious activities within their network. They can also leverage Azure Notebooks for advanced threat hunting using programming languages. Incidents are generated when enabled alerts are triggered. Microsoft Sentinel supports standard incident management tasks such as changing statuses or assigning incidents. Additionally, it offers investigation functionality, allowing you to visually investigate incidents by mapping entities across log data along a timeline. Finally, automation playbooks in Microsoft Sentinel enable automated responses to incidents, making your SOC more productive. These playbooks can manage incident workflows, enrichment, investigation, and remediation tasks as part of Sentinel's Security Orchestration Automation and Response, or SOAR capabilities. So when should you use Microsoft Sentinel? Microsoft Sentinel is a versatile solution for performing security operations across both cloud and on-premises environments. You can collect event data from various sources and analyze it for suspicious activity. Key security operations you can use Sentinel for include visualizing log data, detecting anomalies, threat hunting, investigating security incidents, and automating responses to alerts and incidents. In conclusion, Microsoft Sentinel provides an end-to-end solution for security monitoring, from data ingestion and analysis to incident management and automated response. It's an ideal choice if you want to enhance your organization's security posture with a scalable cloud-native SIEM solution integrated with Microsoft's extensive suite of security tools and services. When you're working in an IT environment, monitoring vast amounts of data to identify potential security threats can feel like a challenging task. So what can you do to efficiently manage this crucial responsibility? In this video, you will delve into the key concepts of log collection and the application of detection rules within Microsoft Sentinel. By mastering these critical components, you will be better equipped to strengthen your organization's security posture and respond effectively to potential threats. Let's start with log collection. Log collection involves gathering log data from various sources such as applications, devices, and infrastructure components and putting it into a central repository. This data is crucial for monitoring, analyzing, and responding to security incidents. Effective log collection is essential for several reasons. It enables continuous security monitoring to identify unusual or suspicious activities, ensures compliance with regulatory requirements, and provides a historical record for forensic analysis. By centralizing logs, you can correlate events from different sources, providing a more comprehensive view of your security landscape. This means you have the ability to review all your security data in one place and respond instantly to threats. Once you onboard Microsoft Sentinel into your workspace, you can use data connectors to ingest your data. Microsoft Sentinel includes many out-of-the-box connectors for Microsoft services that integrate in real time. Data connectors cover a wide range of scenarios and sources, including syslog, Common Event Format or CEF, Trusted Automated Exchange of Indicator Information or TAXII, Azure, and AWS services. After logs are ingested, they are stored using Azure Log Analytics. This storage allows for extensive querying and analysis using the Kusto Query Language or KQL. KQL supports complex queries, joins, and aggregations, making it possible to extract meaningful information from vast amounts of log data. Using KQL, you can write detailed queries to analyze your log data and generate valuable insights. Now let's explore what detection rules are and the various types of detection rules you have access to. Detection rules in Microsoft Sentinel are predefined or custom rules that analyze ingested log data to identify suspicious activities or potential threats. These rules generate alerts when specific conditions are met, allowing your security teams to respond promptly to threats. Within Microsoft Sentinel, you have access to different types of detection rules, including analytics rules, machine learning-based rules, and fusion rules. Let's explore the available analytics rules and rule templates. Firstly, scheduled rules are the most common type of analytics rule. They run at regular specified intervals, analyzing log data based on predefined queries to ensure continuous monitoring. Secondly, near real-time or NRT rules are designed to provide up-to-the-minute information. These rules are hard-coded to run every minute, capturing events as they happen. Thirdly, anomaly rules use machine learning to detect unusual behaviors based on established baselines, identifying potential threats that deviate from the norm. Fourth, Microsoft security rules integrate with other Microsoft security solutions to create incidents in Sentinel from alerts generated by these tools. Lastly, specialized templates includes rules for threat intelligence, fusion, and machine learning behavior analytics, providing advanced capabilities for specific security scenarios. These analytics rules and templates allow you to tailor your security monitoring to your organization's specific needs, ensuring that you can quickly detect and respond to a wide range of security threats. Next, Microsoft Sentinel also provides access to machine learning-based rules. These rules use machine learning-based models to detect anomalies and sophisticated threats that traditional rules might miss. These models can also learn from historical data to identify patterns that signify potential threats. What's more, Sentinel provides access to fusion rules. These rules combine multiple data sources and analytics techniques to identify complex attack patterns such as multi-stage attacks or coordinated campaigns. Finally, let's explore a few important aspects to consider when creating and managing detection rules. To create and manage detection rules, you need to define the conditions and logic to analyze log data, specify the rule logic using KQL, set alert thresholds, enable the rule, and then monitor its performance. Cyber threats constantly evolve, requiring your detection rules to adapt to new attacker tactics and techniques. Therefore, it's crucial that you ensure your detection rules are regularly updated to address new threats and vulnerabilities. You can also integrate threat intelligence feeds to enhance detection rule accuracy. This involves incorporating up-to-date information on known threats such as malicious IP addresses, domains, and file hashes into detection rules for improved effectiveness. Log collection and detection rules are vital components of Microsoft Sentinel's security operations capabilities. By effectively collecting log data from various sources and applying robust detection rules, you can enhance your security posture, quickly identify potential threats, and respond effectively. By now, you should have a good understanding of what Microsoft Sentinel is and how it can be used to collect and analyze logs. Now, suppose you're a security analyst tasked with setting up and managing incidents and alerts. Being able to effectively set up and manage security incidents and alerts in Microsoft Sentinel ensures you can swiftly address potential threats. In this video, you will explore how to configure and manage security incidents and alerts in Microsoft Sentinel. Let's start by exploring how to create analytics rules. Analytics rules in Microsoft Sentinel are vital for detecting threats and triggering alerts. These rules use Kusto Query Language, or KQL, to analyze data and spot suspicious activities. By creating a new rule, you can set the parameters and conditions for detecting potential threats. This proactive approach helps you identify and address issues early, ensuring your environment remains secure. To create a rule in the Sentinel workspace, navigate to the Configuration section and select Analytics. The Analytics page provides a centralized location where you can view, create, and manage your analytics rules. This provides streamlined management and easy access to configurations. In the toolbar, select Create and then Scheduled Query Rule. This will open a wizard to help you set up your new rule. The wizard guides you step by step to ensure all necessary parameters are correctly defined. This also minimizes the risk of misconfigurations that could lead to missed threats or false positives. On the General tab, under the Analytics Rules section, enter the name, description, and severity of the rule. Ensure the name is descriptive enough to understand its purpose at a glance. The severity can be set to informational, low, medium, or high, depending on the potential impact of the threat on your organization. Selecting the appropriate severity helps prioritize the incident response efforts effectively. Next, on the Set Rule Logic tab, define the query logic using KQL. This query will specify the conditions that need to be met for the rule to trigger an alert. For example, you might create a rule to detect multiple failed login attempts within a short period. Next, scroll down and under the Alert Threshold section, set the thresholds for triggering alerts. Thresholds are the specific conditions or limits that must be met for an alert to be generated. For example, in the wizard, you might set the threshold by selecting is greater than and entering 5 to trigger an alert when the number of failed login attempts exceeds 5. You can also configure automated responses, such as running a playbook when an alert is triggered. This ensures immediate action is taken to mitigate the threat, reducing potential damage to your organization. Once you've configured everything, save the rule and make sure it is enabled. Your rule will now start monitoring the specified conditions. Saving and enabling the rule activates your monitoring setup, ensuring that the defined threats are detected and alerts are generated in real time. Now let's explore how to manage incidents that are generated from these alerts. Incidents help you organize and manage your response to security threats. In the Sentinel workspace, select Incidents from the left-hand menu. This displays a list of all current incidents. Next, select an incident to access its details. Here you can find information about the related alerts, entities involved, and the timeline of events. Use the investigation tools to explore the incident in detail. This might involve examining related alerts, analyzing the affected entities, and reviewing the timeline to understand the sequence of events. Investigating incidents thoroughly helps you understand the root cause and impact, allowing for more effective resolution and prevention of future incidents. Based on your investigation, you can take various actions such as assigning the incident to a team member, changing its status, or running a playbook to automate the response. Effective incident response requires clear communication and coordination among team members. Assigning the incident ensures accountability, while automated responses through playbooks can help in quickly mitigating the threat, thereby reducing the potential impact on your organization. Once resolved, you can close the incident or escalate it if further action is needed. Keeping your incident statuses up to date is crucial for maintaining an effective security posture. Closing or escalating incidents appropriately ensures that all threats are adequately addressed, preventing any oversight that could lead to vulnerabilities. Configuring analytics rules and managing incidents greatly enhances your organization's security monitoring and response. Success with Microsoft Sentinel depends on continuously monitoring and refining your rules and responses as threats evolve. Regularly updating and optimizing your configurations ensures proactive threat detection and mitigation, maintaining a strong security posture. You previously learned about log collection, detection rules, and configuring incidents and alerts in Microsoft Sentinel. Now, suppose you're a security analyst tasked with investigating and managing security incidents. Being able to handle these incidents effectively in Microsoft Sentinel ensures you can swiftly address potential threats and protect your organization's assets. In this video, you will explore the workflow of incident investigation and response using the powerful tools available in Microsoft Sentinel. To start, let's discuss a few essential aspects of investigating incidents. Investigating incidents is a critical part of the security operations workflow. It involves understanding the scope of the incident, identifying the affected entities, and determining the cause and impact. This process helps you formulate an effective response strategy and mitigate future risks. Let's explore how to action this process in Azure Sentinel. Firstly, in the Sentinel workspace, select Incidents from the left-hand menu. This displays a list of all incidents that have been generated. You can use the centralized view to prioritize and manage your response effectively. Next, select an incident to view its details. The incident page provides a comprehensive overview, including the severity, status, and related alerts. Having this detailed information readily available aids in making informed decisions quickly. For example, if an incident has a high severity, you can prioritize it for immediate action. Then, on the Incidents page, select the Timeline tab. The Timeline view displays the duration and sequence of events related to the incident. This helps you understand the scope of the incident, how it evolved over time, and identify key actions that led to it. To investigate the scope of the incident further, select the Alerts tab. This view displays the alerts that are associated with the incident. Each alert provides detailed information about the suspicious activity that triggered it. For example, an alert might show repeated access attempts to sensitive files, indicating potential data exfiltration. By analyzing these alerts, you can determine the root cause of the incident and assess its impact. The next step is to identify the affected entities. Entities are the objects involved in the incident, such as users, IP addresses, or devices. Identifying these entities helps you understand who or what was impacted by the incident and how they are related. For example, identifying the user account and device used in a suspicious login can help you trace the source of the threat and understand its impact on your network. Once you have a clear understanding of the incident, it's time to respond. Effective response involves coordinating actions to mitigate the threat and prevent future occurrences. As part of responding to an incident, some of the actions you can take are: assign the incident, change the incident status, run a playbook, document findings and actions, and close the incident. You can assign the incident to a specific analyst or team member. This ensures accountability and helps track who is responsible for the response. It's important to update the status of the incident as you progress through the investigation and response. For example, you might change the status from new to in progress or resolved. Regularly updating the status provides a real-time view of incident handling, ensures transparency, and keeps all stakeholders informed about the current state of the incident. Sentinel also allows you to automate responses using playbooks. Playbooks are collections of automated actions that can be triggered in response to an incident. For instance, you can run a playbook to isolate a compromised device or notify stakeholders. Automating responses with playbooks ensures quick and consistent actions, reducing the impact of incidents. The next important step in the process is to document your findings and the actions taken during the incident investigation. Use the Notes section to add detailed information about the incident and your response. Thorough documentation is crucial for future reference, supporting incident reviews, and fostering continuous learning and improvement. Once the incident has been fully investigated and the necessary response actions have been taken, you can close the incident. This helps keep your incident queue organized and focused on current threats. Properly closing incidents ensures your team remains focused on active threats and maintains a clear overview of ongoing security activities. Now that you understand the steps in responding to incidents, let's go over a few best practices to help you manage incidents effectively in Microsoft Sentinel. Firstly, regularly review and update your analytics rules. This ensures that your detection capabilities stay current with the evolving threat landscape. Secondly, conduct post-incident reviews. After closing an incident, analyze the response process to identify any gaps or areas for improvement. Thirdly, leverage threat intelligence. Integrate threat intelligence feeds to enhance your incident investigation and response capabilities. Finally, foster collaboration and information sharing within your team. Sharing insights and learnings from each incident helps in building a resilient security posture. Effectively managing security incidents is essential for maintaining a secure and resilient IT environment. By thoroughly investigating incidents, identifying affected entities, and determining the root cause and impact, you can develop an effective response strategy. Regularly reviewing and updating your analytics rules, conducting post-incident reviews, leveraging threat intelligence, and fostering team collaboration are all critical practices that enhance your incident management capabilities. Proper incident management not only mitigates potential threats, but also strengthens your overall security posture, preparing your organization to handle future challenges with confidence. Congratulations on completing another module of this course. Throughout this module, you've gained essential knowledge of crucial Azure services and now have the expertise to use and manage critical Azure resources effectively. But before you move forward, let's take a moment to recap the core topics you've learned. Revisiting this content will ensure you're fully prepared for the upcoming module quiz. You began with Azure Identity and Access Management, or IAM, and discovered that, like controlling access to secure areas in a building, IAM ensures that only authorized users, machines, and applications access the right resources at the right time. This includes first authenticating an identity and then authorizing the level of access an authenticated user, machine, or software component has to a specific resource. You then discovered how to manage users, groups, and roles using Microsoft Entra ID. Here you explored the process of creating, updating, and deleting user accounts and assigning appropriate access levels to ensure security and compliance. You also learned about creating and managing groups to efficiently grant users with similar resource access requirements the appropriate permissions and streamline administration tasks. Next, you explored how to implement role-based access control, or RBAC, in Azure and how it allows you to assign roles to users and groups based on their job responsibilities. You learned how RBAC ensures that the right users have the right permissions to perform their tasks, reducing the risk of unauthorized access. Lastly, you explored how to implement custom roles in Azure, as well as the best practices when you create custom roles and assign access permissions to meet specific organizational needs. You discovered how custom roles enhance both security and operational efficiency by providing granular control over resource access. In the next part of the module, you moved on to the purpose and functionalities of network security groups, or NSGs. You explored how NSGs act as virtual firewalls, controlling inbound and outbound traffic to Azure resources. Here, you discovered how they help protect your resources by allowing you to define security rules that manage traffic flow between various parameters such as IP addresses, ports, and protocols. Following this, how to configure NSG rules to enhance the security of your Azure virtual networks was covered, where you learned how to create an NSG, associate an NSG with a subnet or network interface, create security rules, and test and validate rules once they have been created. Then you explored advanced NSG rule configurations and best practices, where you learned about augmented security rules, which combine multiple IP addresses, ports, and protocols into single rules. You learned how you could, for example, create a single rule to allow traffic from multiple trusted IP addresses to specific application servers, simplifying rule management and enhancing security. Integration of NSGs with Azure services like Application Gateway and Azure Firewall was also discussed. These integrations enhance your security posture and traffic management capabilities by providing additional layers of protection and control. This also covered automating NSG management using Azure Policy, Azure Resource Manager or ARM templates, and Azure DevOps. You learned how automation ensures consistent and efficient security configurations, reducing the risk of human error and streamlining security operations. Furthermore, for complex network security architectures, you learned about segmentation patterns like single virtual network, VNet peering, hub and spoke model, and managing multiple VNets across subscriptions. You discovered how these patterns help you design secure and scalable networks. For example, the hub and spoke model that allows centralized management of security policies, facilitating easier network management and improved security. In the final part of the module, you were introduced to Microsoft Sentinel, a cloud-native security information and event management, or SIEM solution. You discovered how Sentinel provides comprehensive security monitoring, data ingestion from various sources, threat detection, and automated response capabilities. You also learned how it leverages machine learning and built-in threat intelligence to help you identify and respond to threats quickly. Additionally, you learned about Sentinel's seamless integration with other Azure services and its scalability to meet your organization's security needs. You then covered log collection and detection rules in Microsoft Sentinel, focusing on gathering data from various sources and using Kusto Query Language, or KQL, for analysis. You learned how effective log collection is crucial for continuous security monitoring and threat detection. For instance, Collecting logs from firewalls, VMs, and applications provides a holistic view of your security posture, enabling proactive threat detection. Next, you explored configuring security incidents and alerts in Sentinel. You learned to create analytics rules using Custo Query Language or KQL to detect threats and trigger alerts and set alert thresholds for proactive threat detection. Additionally, you covered configuring automated responses with playbooks and managing incidents by examining alerts, assigning incidents, and documenting findings. Finally, the workflow of investigating and managing security incidents in Sentinel was discussed. You learned about thorough investigation, root cause analysis, and effective response strategies, and how this ensures that you can swiftly address potential threats and protect your organization's assets. You discovered how, using the investigation tools in Sentinel, you can map the timeline of events, identify affected entities, and determine the root cause of incidents. Additionally, throughout this module, you engaged with various videos, readings, and activities that provided you with a solid foundation in Azure IAM, network security, and security incident management. Great job! You've gained valuable insights into essential Azure services and their practical applications. By engaging with this content, you've continued to enhance your Azure skills and gained the knowledge necessary to navigate the Azure ecosystem effectively. Congratulations on nearing the completion of this course. You've put in a lot of hard work and you should be proud of your efforts. Watching this video means you've successfully navigated through the content of our Azure Cloud Services course. You've explored the fundamentals of cloud computing and discovered the advantages of various Microsoft Azure solutions, including Azure Compute, Azure Kubernetes Service or AKS, and Azure Networking. By now, you should have a solid grasp of the following: Azure Compute, understanding virtual machines, app service, and AKS. Azure Networking, including virtual networks, load balancing, and routes. Azure Security, including knowledge of Microsoft Sentinel and best practices for securing virtual networks. Techniques for troubleshooting operating systems on Azure virtual machines. And lastly, key networking features like scaling, load balancing, network security groups or NSGs, and Azure Sentinel, which enhance management and security. Before jumping into the course project and final assessment, let's take a moment to review everything you've learned. This recap will ensure you're fully prepared for the next steps. Keep up the great work. You began the course by discussing the key concepts of Azure virtual machines, exploring various deployment options available, including deploying through the Azure portal using ARM templates and Azure CLI. Each method offered unique benefits, from ease of use to automation capabilities. You also practiced deploying VMs using different methods and studied advanced configuration options such as custom scripts, managed disks, and virtual network integrations, which allow you to tailor VMs to specific needs. Next, you explored the best practices for optimizing VM performance and security. Remember, using Azure Monitor, keeping VMs updated, and employing Azure Security Center are essential steps in maintaining a secure and efficient environment. You then covered Azure App Service, exploring its key features and benefits, which include easy deployment, built-in scaling options, and integrated DevOps capabilities. You studied various deployment and scaling strategies for web applications, which make it easy to manage web apps. You also practiced deploying web apps with Azure App Service, following a step-by-step process, and read through different scaling strategies, both manual and automatic, that ensure your applications can handle varying loads. Moving on to container orchestration, you explored the role of AKS and studied the steps involved in deploying and managing AKS clusters, including setting up nodes and deploying containerized applications. You also covered cluster management, security, and best practices for deploying containerized applications. Practical experience in managing containers with AKS highlighted the importance of network policies, RBAC, and regular updates. Additionally, you discovered that Azure Virtual Networks form the backbone of your network infrastructure, and you also explored several subnetting techniques, network security configurations, and advanced options like NSGs. Then, best practices for securing network traffic within Azure Virtual Networks were discussed. These included configuring NSGs, using Azure Firewall, and regularly reviewing security rules to ensure optimal traffic management and security. Following this, you discovered that Azure Load Balancer and route tables are crucial for distributing traffic and controlling network routes. You explored load balancing algorithms, configuring rules and best practices that ensure high availability and reliable application delivery. With route tables, you learned to control network traffic, configure static and dynamic routes, and how to optimize traffic management, ensuring a robust and efficient network. Identity and access management, or IAM, was another critical area. You explored how to manage users, groups, and roles through RBAC, as well as how to define custom roles to maintain security and compliance. Next, best practices for securing access to Azure resources through IAM demonstrated how to configure roles and permissions carefully to ensure only authorized users had access to critical resources. You also discovered that NSGs play a key role in network security. You explored NSG rule configuration, advanced configurations, and best practices for creating complex network security architectures. In the last section of the course, you explored how Microsoft Sentinel is used for security monitoring. You looked at log collection, detection rules, and best practices for configuring security incidents and alerts. You then discovered that the workflow of incident investigation and response in Sentinel is crucial for maintaining a secure environment. Setting up alerts and following best practices ensure timely responses to potential threats. Finally, in the last part of the course, you implemented and managed log collection and detection rules in Sentinel for a given scenario. This concludes our recap video. Now you will undertake a project to implement a secure, scalable Azure environment that incorporates a virtual infrastructure. Throughout this course, you have gained valuable knowledge on various Azure cloud services. You now have a solid understanding of their features, advantages, and use cases, preparing you to apply these skills in your final project and graded assessment. If you need a refresher on any topic, feel free to revisit the course materials. Good luck! Congratulations on reaching the end of Mastering the Cloud. By completing this course, you have developed a solid understanding of what Microsoft Azure solutions are available, including Azure Compute, virtual machines, app services, and Azure Kubernetes Service, or AKS. You've also explored Azure Networking, which covered virtual networks, load balancing, and routes, and developed a solid understanding of Azure security, including Identity and Access Management, or IAM, Network Security Groups, or NSGs, and Microsoft Sentinel. Through a mix of videos, readings, and activities, you've gained a solid foundation in the benefits and use cases of several Azure services, the deployment and management of virtual machines, various scaling strategies, and key networking features that enhance the management and security of Azure. Additionally, you completed the final course project where you deployed a secure and scalable Azure environment. Well done on taking the next step toward your future career. Remember, by successfully completing all the courses in this program, you will earn a Coursera certification. This program will enhance and deepen your cloud technology skills. This globally recognized certification significantly boosts your credibility and appeal to prospective employers. Additionally, it showcases your dedication to ongoing learning and career growth. Completing the program also serves as an essential stepping stone in your preparation for the Microsoft Certified Exam AZ900 Microsoft Azure Fundamentals. Passing this exam earns you a certification that provides industry-endorsed evidence of your skills, further enhancing your employability and career prospects. This AZ900 Microsoft Azure Fundamentals exam demonstrates your knowledge of Azure components and services, including compute, network, and storage. It will also test your understanding of key skills, including cloud concepts, Azure architecture and services, and Azure management and governance. In summary, this course has enhanced your knowledge and skills in key aspects of cloud computing. However, you might wonder what lies ahead. There's still more to discover, making it beneficial to enroll in the next course, where you will study several crucial aspects of Microsoft Azure, including the essentials of identity access management, and further explore the creation and management of virtual networks. This course will demonstrate how to maintain the security of Azure environments and encompass a comprehensive study of Microsoft Entra ID, Identity and Access Management, and network security groups. More specifically, the course will allow you to describe Microsoft Entra ID and its role in Azure, troubleshoot Entra ID related issues efficiently, implement identity and access management in Azure, create and manage virtual networks in Azure, and configure network security groups for enhanced security. Additionally, you will witness key Azure networking features, including virtual networks, load balancing, NSGs, and Azure Sentinel, which provides enhanced management and security for your Azure resources. Upon completing this course, you'll possess the expertise to implement identity access management and ensure the security of your Azure environments. The skills you have gained so far showcase your ambition, competence, and readiness to tackle new challenges for any new employers, and you should be proud of your progress. Wishing you continued success as you continue down your educational path.